radically different.
in the
And if you want to take the analogy,
computer and
take,
in the
for example,
platform
the electric
to help
bulb
us to find
and
more
the
interesting
candle.
things or give our
Both the candle
help,
and the electric
help
bulb
recommendation
gives
and so
light.
on. And the machine will be more.
But the electric bulb is
more
not just a
important
powerful
and more
version of a
complex.
candle because
So
they operate
the
in a
knowledge
totally
graph
different principle,
is
entirely different.
will
In a similar
to
way, quantum
address
computing
this problem,
is radically different
problems.
from
And
the computing
then we
paradigm
find
of the conventional computer that
knowledge
we are all
graph
familiar with.
refers to the
So what is different?
assemblies of knowledge elements
The quantum computing
their
is based
relations
on
described
the
in a
quantum mechanics
structured
principles,
form. You can
which is
find
derived
in
from quantum
the
physics.
Past. The
So that is what
informations and
makes it
the
different.
knowledge
The
is
quantum computer
appears
is
in the
based on,
raw
as of
mass
course, name
disconnected
implies,
documents,
based
such
on
as
the quantum
videos or
mechanics
texts
principle.
or
So it is a entirely
Excels and
different
so
way of
on. It
operation.
is very hard to
And that's
carry
what
on,
gives
analyze,
orders of
and
magnitude
visualize
faster
for the machine.
ability
Maybe
or
it is
magnitude of
very
faster computing capability
easy
to address
analyze
some
by
of the
a
kind of
human.
problems that
Maybe
are
he have
unsolvable
to
by
very
traditional classic.
familiar with this document.
So in that sense,
If a
it is
human
a
is not
totally radical
familiar with
new computing
these
paradigm.
documents, it is hard to find
So how
the
fast it can go?
informations.
So according to one estimate, it could go
to get the
of order of
relationship
million
of these
times
documents
faster
or
than
this
the conventional
information
computer.
or knowledge. It is
Just to give you an
knowledge
example,
graph give
as I said here,
solution,
a
resolution
problem
on this
that
problem.
could take up to
He
10
collects
years
different elements of
using a
knowledge or
conventional
information
computer could be
collected.
solved within 30
This
minutes.
make them
You see
more
that
clean,
how good it is,
organized,
how
and
fantastic
linked.
it would be
The links
if a
information
problem that could not be solved
it is
for a
very
10-year period, over a
variable
10-year
and
period
very
of computation,
readable for
could be
humans.
solved
It
within
is also
just
very
5 minutes.
readable for the
Actually,
machine.
this is not
We
a
intend
hypothetical
to
one. This is a real
make
case.
machine
In Germany, Deutsche
the
was
relationship of one
bank.
point
They
to other point or one station
initiated
to
a
other station,
quantum
one
computing
machine
pilot
human to
application
other machine.
to model
It is very
enterprise
easy
risk.
query,
If
analyze,
they
and
wanted to take
visualize
into
for the
account
machine.
all
For the
kinds of
machine.
risks
So
and the
this is
probabilities involved,
the
the
knowledge
intensities
graph.
involved,
And
it could take
we
up
know
to
it
10
is very
years
important. So
for
we start
10
this
years of computational time
standardization
to calculate the risk.
from
So whereas
2018.
the quantum computer
And
could do it just in 30
next,
minutes.
we
So that is
machine
how
motivation
that is the
knowledge graph
range in which we are talking
standardization.
about
We know knowledge graph
orders of
is it
magnitude
is very important.
improvement
However,
in the speed
we are
and
not the
capabilities.
researchers of
And of
knowledge
course,
graph
why we need to learn
We
about
just
quantum
focus on
computing,
its
quantum computers
standardization.
matters
So
to
we
us
find some
either as a
standardization
professionals and
demands
engineers
among different
and
stakeholders
IT
because
professionals,
the
or even
stakeholders
as a
have
layman,
their
it matters to us
experience,
either
individual
directly or
experience on
indirectly.
knowledge graph, and
So
their
that's why there
individual
is a lot of
research
interestedness.
on knowledge graph.
So as
How
a
to make
professionals,
them
we need to
communication.
learn about it. We
It
need
is
to
very
be
important.
aware
Because,
of it, what it
maybe
is, so
researchers
that we can come into the
expertise of
party
graph,
when it is
knowledge graph.
needed.
However, the
So
user
we'll
and
just
the
look at it, what
integrator, it
quantum
is not
computing is
familiar
that, how
with the
does it
knowledge
work,
graph
and who are the
technologies. He
major
just
players,
wants to know how
and what
to apply
impact
the
it
knowledge
might
graph.
make. So we'll have a
We
quick
have
overview of
difficulty to
this.
communicate user and
So what
researcher
exactly is
and the
quantum
provider.
computing?
So we think they need a language.
So as I mentioned
common
earlier,
language,
the quantum computing is a form of
standardized
computing
common language for
based
them
on the
to
principle of quantum
them
mechanics.
connect different
So what are the
stakeholders. And next,
principles
we find
that are
so
exploited
sorry.
in
So
quantum computing?
it seems
There
to
are
me
two
that you are doing
principles of
some
quantum
very
mechanics
great things. You
that
know
are
what you
exploited
do is
for
now for
quantum computing.
2807 in
And
your
one
working
is
group
known
is
as
now a
superposition,
platform. You connect
other is
the
called
researchers
entanglement.
with the
I
real
will quickly
users who have the
describe
demand
each
of
one
the
of them
knowledge
Hello.
graph, and they need to
soon.
link
Hello.
Yes, ma'am.
use
Can you hear me?
different
That's it.
Yes,
AI
yes. Sir, you
applications
can
for
start the
different
session, sir.
domains,
Meanwhile,
right?
they will be
So-
joining.
So you are doing something on
And
that,
like
right?
a conventional computer,
Almost
we
70
call the
students
bits
have already
in a
joined.
similar way.
No problem.
The
Quantum
initial
computer,
idea
quantum
from
bits
us,
are
we
called
want to
qubits
standardize
in
the
short.
Okay, so good
knowledge
afternoon
graph
to one and all.
because we have
Welcome back to the second
Qubits
session
for
today
short.
on
different
machine learning.
And
terminologies.
Uh,
the
Before I
comes
go
from
ahead,
I
I'll
would
just
because of
maybe
the
have a
some
quick
say
recap
it is
of
knowledge
yesterday what we did.
optimization.
and the
Some
entanglement.
say it is knowledge
For
computing.
instance, when you talk
Maybe
about the
they are
quantum
So we
mechanics,
talked
thinking
about
of
we are
AI,
certain
looking at
we
the
talked
things.
about
subatomic
However,
level
they are not
phenomenon.
definitions
machine
of
learning
them.
definition,
So,
They
like
don't
right?
know.
unlike the
And
traditional
they are
physics,
different.
or
And
So
we
the
they,
very
why
here
they
the
say
quantum
which
that
I
physics
told
we
you
look
need
that
at
some
you
some
basically have the
particle
historic
behavior
data.
at the
You train the
address
subatomic
this
machine
level,
using
problem.
that historic
and
This is
data,
that
and
leads
the
to
machine will
some of
try
the
to
phenomena
derive
what is
a
called the
pattern of the
quantum
data
mechanics.
and be able
hence
to
we
predict
find
the
So,
output
what
for
is
maybe
the
any given set
knowledge
of
superposition?
input
graph
data,
have been
right? So this
applied
is
to
We
very
different
know that
important when it
in a
comes to
industries.
machine
canonical
learning.
There are
computer,
some
Uh,
related
the
system
binary
we
bit
talked
application
about
cannot
system
RCA.
by
Okay, we talked
production
about
either
service
one
can
of the
be
two
the
states,
various
either
applied
zero
types.
provide
or
to the
one,
users.
either one
So
of the
we
However,
talked
the user
about
is
don't have
not
the
the state.
regression.
Whereas
We
expert
talked
the
about
quantum
knowledge on
classification,
computer,
knowledge graph.
right?
they
So
They don't
could
know
regression
be,
was
how
where
because
why
of the
can
independent
control the
variable was
quality, how
superposition
continuous.
to
of the quantum
Whereas
manipulate the
in
knowledge
this
mechanics,
graph
case, the
system.
independent
the
variable
Because
subatomic
the
is
knowledge
particles
discrete.
system
could
The
be in a
dependent
state
variable
of
is discrete. So
structure
that
superposition,
is basically
which
the
construct
means
difference.
it's a
knowledge
Okay,
graph.
let me just share
combination
my
For
of
the
screen share.
user,
Oh,
zero
sorry.
and one
he is
simultaneously
more
I didn't
want
share my
to
with
screen.
some
apply
probability
this
or change.
system to
So
address
partly
some
zero
Sorry
or
about that.
partly
problem in
one
his
is
domain.
possible.
So
That
its
is what the
management of the
property that the
system or
quantum computing
product
makes
or
use of.
service is
That's called
most important to
superposition.
the
Is my
users
screen
And the
visible
or
to
the
all?
entanglement, I
integrator
will come
of the
to the
knowledge graph.
next.
And also
Yes, sir.
the
So the
knowledge
quantum
graph
mechanics,
So
is
we
as I
talked
said
about
earlier, this
two
knowledge.
behavior
scenarios
at
We
the
in
know
supervised
subatomic
the
model.
level,
One
knowledge is
scenario called
not
and
regression,
we
where the
absolutely
go to
output
right
the
or
or
the
detail.
independent
absolutely
variable is
wrong.
continuous.
Although
It is
the
And
quantum,
this and
the,
where
it
we
the
also
is
talked
phenomena
about
of
the
being
quantum
Lee-Wave
mechanics
relation,
has
in
been
two
known for
which
a
bites
is an
long
according
time.
example
to
of
the
years of
new
experience,
Only in the
salary
last
and years of
30
40, 50
experience
research.
years,
So
was
we
the
the
find
independent
this
variable
concept
is
of
and salary
using
was the
or
dependent
dynamic
variable.
and
exploiting the
dynamic.
quantum
We
So
also
mechanics
we need
talked
to
about the
for
multivariate
manipulate
regression,
computational
it by
where, for
the
purposes
user
example,
field
has
somebody
come
talked
because
into
about
it
price
is
of
existence.
just
gold,
the
And that
expert
and
too,
we
the
also
only
talked
in the
about price
last
of a
such
30,
house,
as the
15
because of
years,
manufacturer
various
there has
or
been
such
factors,
as
major
the
various
medical
features.
interest in
and
the
the
And
provider
then
of
the
the knowledge
second
graph
computing.
system. It is
aspect of
just
The
supervised model
quantum
is
mechanics
where
researcher,
your
principle
independent
expert,
is
variable is
used
discrete.
in many other devices
researcher,
as
And
well,
when it is
which
provider
discrete,
are
we are
of
we
the
talking
are
about
knowledge
currently
graph
class.
using it.
system. This
So,
is
for example,
different.
And
LED,
the
So
ASs,
example is
when we
if a
the
need
person
to
is having a
GPUs,
improve
cancer
the
or
magnetometer
not,
quality
if a
of the
person is
sensitivity,
system
buying a car
all
or
of
not
them,
buying a
and the
car,
these
quality of
or
some
the
of
if
the
there is a
knowledge graph.
properties
specific
are
The knowledge
discrete
in
set of
quantum
system have
mechanics.
two
images,
parts.
whether
So
it's a
One
the
is the
dog,
quantum,
knowledge
the
cat,
graph,
or
and
any
application
the
of
other
one
quantum
is the knowledge
mechanics
animal.
system
is not
field.
new.
So
So
What
we
is new
we
is
think
basically
that
it is
have
very
application of
sophisticated
important.
quantum
algorithms.
So
That
this
is
mechanics
what
is
is called
also a
to
very
classification.
important
computing
We
purposes
also
uh,
talked about
is new.
unsupervised model,
That's
and
what
we
is
within that we talked about
standardization
clustering and
amount.
learning association. And
And
learning association, we
So as I
next,
took
said,
we
the
found
quantum
examples of
the
computer consists of
recombinant
development of the
intelligence, like a
and the
quadratic
application of
say
combination
knowledge
or the
graph
movie
in
called
recombination.
various
That is
quantum
domains,
example
such
of
it can
as
be both
learning
on and
industry,
off
association. And then
based
and
on
finally, we
because
talked
it
intensity.
is
about
different.
So
reinforcement
basically,
So we
it
learning,
need
is in
to
a
where
follow
we
complex
took
state
the
different
example of a
standards
of
robot,
and
where
complex
guides
when
from the
imaging
suppose
different
state
when a robot
domains,
goes
be
and
from
in a
one
also
state to another
superposition
the
based on an
state.
action,
the knowledge
and with that
structure in different
state
So
is
let's
domains
moving
look
towards
is
the
at the
desired
different.
goal,
complexities.
then it
So
gives a positive
we
This
reward,
particular,
find
otherwise it gives
further
a negative
say,
reward. And the
graphic
the
idea is how to
detailed
explains you
maximize
guidance
what
in
we
these
mean by
the
that.
different
positive reward.
domains to
So the
make the
qubit,
user
so
Then
the on
I
the left
talked
more
about
side,
the
this
worst
has
understood
a
case
according
involvement,
and
conventional,
also
and
provide and the
say,
we
developers
talked about
bit
the
have
or a
data
binary
pre-processing
to
bit.
know
phase, the
how
So either
model
can
it can
training
be
be
phase,
either
the
zero or
then the
one,
qualified
model
in
and
another
evaluation
very
phase,
expression.
where we are
applicable knowledge
Whereas on
evaluating the
the
graph and
model
the
right
based on the
knowledge
side,
graph
test
what you
data,
see
integrated
is a
system.
and then the
quantum bit
model
or a
deployment.
qubit.
And we
Once the
For
basically
model
each,
is
you see
yeah.
here,
Yeah,
the accuracy is
basically
according
the
to
more
the
than
frame
time,
threshold,
iteration
it
and the
could be
frame
which is
iteration
85%,
partially
convention
then
zero
and
or
we
we
deploy like the
for,
model
for
tree.
not
Takes
only
a
researcher but
a
also the
complex,
industry,
space,
because it's really
In
leads
quantum
the
data
market
zero
demand.
and one,
So,
we talked
and
about
in a
becomes,
nutshell,
that means
what
that
do you think about the
labeling codec.
advantage of
we
the
talked
knowledge
about
of
various
standardization?
one
right?
and
One was
partially
the
zero.
importing
From
the
your
library
working group and from your
Then,
expert
importing
point of
the
view,
data
when we
set,
make a
and
measurement,
when we imported the data
it
set,
boils down to either one of the
after
states,
importing the
either
data
0 or
set,
1.
it could be any
this is,
format,
So it
CSV
depends on a
format,
quantum
PDF or
mechanics
text.
stage.
Then we basically
Separation.
identify which are the independent
But when you sense
variables
it,
and which is the
when you
big
measure
variable.
it,
As I said,
then
there'll be
it
one
boils
dependent
down to
variable
0 or 1.
in the supervised model,
Since
but
it's
there
possible
n
to
number
be
of independent variables.
in many stages,
Then after that,
many
we talked
stages,
about data
then that
categorization,
leads
where
to
we, as I said,
higher
since
computation.
machine learning algorithms
So
don't
this is one
understand
of the
text, we
phenomena
need to convert
that
it
is
to number
exploited
or
in
binary
quantum
format.
computing.
That's where we
Leads
use
superposition.
data categorization to convert text
So
into
you can occupy
binary, and we use a label
multiple
encoder to
states,
convert into a
which is
serial
partially
number,
zero
and then
and
one hot encoder to create an array of dummy variables,
Then
right?
knowledge graph and how to
let's come
applicate.
to
And then we
the
also
other
talked
part.
about
We have
then
different
splitting the data
Basically,
into
the
training
quantum
set and test
computer
set.
makes
And
use of
finally,
the
feature scaling,
uh,
where there
say,
is features which are
the
different
quantum
scales.
mechanics.
We need to bring it to a
The
common
two
scale.
key
So we
among
have
them is
functions
the
like the feature
superposition
scalar and
mechanics.
the standard scalar
So
bigger
what is
And the
purpose.
entanglement is
min-max
that
And the next,
to do the
we
one
think
bit
is used to bring it down to
affects the
standardization
other.
can give
common
the
speed,
unified
small value
performance
In a
evaluation
traditional
index
computer,
system.
the status of one bit
It
doesn't
will
affect
having
the
talked
status
about
of
the
the
that,
guide for
But
let us
whereas
go through
in
some small
quantum
examples.
computer,
and the next
So,
clear
anyone
main
who can
activities
answer
of
this question?
affect
Nordic
the
graph
qubit
and
2
controllers.
and
Ideally,
qubit
out of
2
the
affect
It
qubit
is
3
but,
and say
we will
basically
do
they are
Nordic
all
graph
it over
provider.
entangled.
When
So they are all
every
correlated.
question could have
Nordic
There is
graph,
a
multiple
lot
right
of
answers.
correlation
he
between
have
the
So you have to
two,
give me
and
the
that's
correct
what
answer.
the
main
entanglement
activities.
is.
So whatever we have
Each
covered
So
activity
today,
you take
can
the
up to now,
superposition of all the
I wanted to
states,
see how
purpose.
then
much
you
And
have
remember, how much you know,
exponential
he
increase in
has
the
a different
capabilities
purpose
of
of
the
activities. I think
say
some
capabilities
and whatever
activities
corrections
is
need to be done,
not
we will do that, right?
optional.
that leads to
He
So
have
question
to
number
do
one.
increased
some
quantum
activity. It
computing
is very important.
capabilities.
And
So it's
also
based on
for
the
the
two
users or
principles. One
other
is the superposition,
partners.
that is the
Next,
qubit can
we
be
think
Which
the
are the
say
examples
multiple
of machine
states,
learning applications?
say being
requirements and
0 and 1 this one,
guidelines of knowledge graph
and one
construction,
qubit affects the
integration,
other
and
case, they
application
become,
in
these are all
specific domains.
entangled,
Either
As
write
I
the answer
said,
in the
connected or
chat box,
maybe a
interrelated.
common
So that
or you
is
can
called as
activity, main
entanglement. There is
activity
a
of
correlation between them.
construction,
And then
integration,
you take the measurement and then
application
finally
is not enough
so
for
that
a
is two of
specific
the
domain, such
key
as
principles.
I just gave an example
So like
for the
binary notation,
medical
the quantum
or
computers, you
manufacturing.
use what's called as a
For
ket
example, we have to
0 and ket 1
Yeah.
notation.
we have
And
to
that's
Please
what
answer the
we
first question.
explain.
Anybody of
So
you?
we
we
don't
can
have
get
time
the
And
to
when you
go
write
into
the, when
details
you
of how
answer, please write the question
top
and the
respect
option.
to
And
that.
please
This is
note
how
that
we
there are
represent
multiple
the
right
qubit
answers. So please
using
put
ideas
in your
or
response.
other
So that is
features.
the
How to
basics of
get
the
the
quantum
top and
computing.
the common
So that's
structure in
that's
the
what it is the first
knowledge
from the
modeling.
traditional computer.
We have
In
to
the way
communicate
that
with
the
the
qubit
domain
differs from the
experts to obtain
What is the answer?
And when
You
it
said
comes
prediction
to-
model. Okay.
there are different
expert
types of
types
quantum computing.
knowledge
So
in his
I'll
mind.
just show
I
you.
think
Okay.
there are some
Prediction model, fraud detection.
communication
Anybody else?
There
works
are
in this
because
in
although
this
the quantum
activity.
computing
Okay,
principle
now we are
If
or the
we
superposition
have
and
to satisfy
the one who says
many
prediction
guidelines
model.
or standards, we
Okay,
we
anybody
can
else?
to
various
Very
ways
sharp.
we
get
can
this
realize
information
the
in our
quantum
standards
Shanti there?
or
And
some
according
other
to how it is
tasks,
realized,
purpose,
then you
details.
can
I
classify
think it
Which
is also
one?
very important.
three categories.
So,
Oh, you
One is
answered.
called
is
quantum
some
annealing,
advantage of
other
for the
is quantum
standardization of
simulation,
knowledge graph.
and is universal
Great,
At
Wei
Right,
Qi. So it seems
what is
to
the
me
As you
that
see on
you
the
which are the
chart there,
examples of
really
machine learning
identify
quantum
a
applications?
great
annealing,
opportunity
we are not
power
talking
is
about
to
model.
really define some common
and it is
When you
language
talk
or
of prediction
framework
model, it's a
implement.
model.
for people
And the
in different
quantum
domains
simulation
to have the
future
same
state, there's
language to
something
talk
called
to
time
one
series
another,
analysis.
Simulation
to understand
purposes.
one
For
another
That
about
one
the AI
is a bit
application
hard
Find
to
out
and
implement.
about the knowledge
And
the
graph.
future
similarly, the
state
capability
of a
I
company
just want to
and
know
the
in
rest
this
of
data
really
set,
quantum
what
right?
is further.
So that's a model,
the
not
exact
an
the
purpose
quantum
and
application.
need. I mean,
is
based on the advanced stage you
basically
Fraud
use
detection, if you
to
remember,
the
it's an
establish the
application.
computer
Right?
science,
Talked
I mean, the
about
computer
a
society
machine learning
PCI
algorithm can identify
X07
a
standard.
fraud transaction or a
Sure,
Can
normal
you
what
share
the
with us a
quantum
little bit
annealing
Google
more
is.
search,
about,
yes.
Quantum
the
annealing
exact
is
purpose
best
and
for
need for
solving
this
the
Google
standard that
chatbot
you are
optimistic
is
leading?
also an example. We talked about
any kind of
RNN,
optimistic
super
problem.
neural
But
network,
in fact, if you look at
which are
it,
typically
maybe
used for
in
this
practice,
is
you
just a
find
chatbot
standard.
application. Okay, so the
optimization
answer is
requirement
DC
in
and
many
DC.
areas,
Just
whether
all
it
the
is the
standardization
transport
demands.
or
An app
the
is a model, not an
say
application.
financial
the standard
Let us see who is
computation
smart enough
for
to give
optimize
this
framework of
certain
knowledge graph.
profit.
We
So the
want
Question
optimization
number two,
and the
address the
manufacturing
most
or even
what are the various
drug
machine learning
discovery.
types?
There are many areas where
Let me
you
see who
need to
can give this
optimize
answer
things,
correctly.
particularly in the
standardization
engineering.
demands.
And
First,
quantum
we
annealing
want to
is best
define
for
the
that.
frameworks of
Just to
knowledge
give an
graphs,
example,
especially
let
the
us take the one
terminologies
which is
and
highlighted here.
the technical
And
Very
once
framework,
again,
how
one
the
with
automobile
the
manufacturer
activities and
the
tasks
say, conducted a
in
study
different stages
so
of
it
the
also
to look at the
processes.
potential of
And
the quantum
this
computer.
will help
So
the
basically,
anybody
they
in
enterprises
wanted
the
to optimize
audience.
and the
traffic flow
SMEs and
in the
others which
overcrowded
develop
Beijing.
application to
What is
follow
So
the
you
answer
know
for
that
question
how
number two?
general
crowded
knowledge
the
graph
Beijing traffic
construction
is,
methods. This make
So
different
basically, they found that
stakeholders or
the quantum annealing
developers can
principle,
focus on
quantum
a
computing based on the
small
quantum principle,
stage of
where
the
they were able to
processes. They can
successfully
communication
reduce
with
the traffic
Nagesh, you say
others.
supervised
by
learning is
optimizing
very
the
good.
Enterprises
traffic
is
rules
focused
and
on
other
the knowledge
patterns.
Anybody else?
modeling.
So there are many,
Some
and similarly there are
enterprises
many
will
examples.
focus
So
on
the
the
Airbus
knowledge
is using
pyramidization.
Shanti,
They can
for
communication,
modeling
A and B,
the
very
cooperation
nice.
with
and
others
other
to
things.
address
And the quantum
common
mechanics
Anybody
principle
purpose
is used
or
by
common
many other. That is
project
the
in
quantum annealing.
the first.
The
And the next
other
we
aspect
want
is
to
what is
adapt
called
the
as the
digital
quantum
infrastructure
simulation.
I always
of
remember
knowledge
in
So
graph
the
basically,
faculty also it is very good.
used for
understand the
new,
knowledge graph
new
diagrams
discoveries,
and
Somebody
quantum
types it
chemistry,
very good
more
in
efficient
and other
everybody
areas
starts
where
answering A and
to
you
the
B.
want to
knowledge graph.
simulate
Shanti,
the
Because
Shivani.
we know the knowledge graph
so
I'm
that
not
you
saying
can
you're wrong,
come
but
up
you're
with
partial,
smart
but
materials,
you're partially
new
right.
drugs, new
we can
fertilizer.
find
Can
This
somebody
is what the
be a
quantum
more
simulation is
many,
used for.
think a little
And
more
the
and
other
tell me
is
what is the right
universal
option?
quantum computing.
activities
That
such
is
as
the
the
much
NLP,
wider
such as
general
the
purpose quantum computer.
machine
So
learning,
these are the
and
three
some maybe
basic
some graph
concepts used.
computing
That is
technology.
annealing
So he
and
need
simulation
many
and
tools
what is
to
called as
support
the
it.
universal
So
quantum.
And
supervised
uh,
learning, yes.
if
So that being said,
digital
let us look at the
infrastructure
Learning association
supply, it
the
is more
is
quantum
also
familiar
computer
with
it is
the
part
is
of
realized.
unsupervised learning.
diagram knowledge graph.
There are
He can
many
find
We talk
ways
of unsupervised
which
learning.
problem
We
you
talk
can
about clustering and
implement
learning
quantum
association.
he
Remember?
want to focus to
And
address.
interestingly,
We
The
always
tool
look at
will
the
be
main
more
heading,
major
but we don't look at the
say
sub-points.
IT companies are looking
also
at
Right?
can
Chatbot is
problem
an application,
in a
yes,
slightly
not a
different
type, I
perspective.
can
agree.
They are
Reinforcement
trying
learning
to
is
use
also
communication and
different
right.
cooperative
So
with
the answer is A,
So
B,
in
and
the
D.
developers
chart,
of
I
knowledge graph.
highlighted it.
And
What type
most
of
of you have,
technology
wherever
they
I've
are
had colleges,
they're working on,
95%
and
have
what
almost
is
been
the
A, B.
which are the companies they are working
Machine
There are
on.
only one or two
framework
colleges, one or
So
two guys
currently,
who are
there
and
are at
your
least
answer is A, B, and
4 or
vertical
5
be careful when
applications
you
major
answer
type
try
of
something
say
hidden.
more
qubit
enterprise
technologies
Okay,
that are
that's
being
fine.
experimented and
and
developed.
Question number 3,
generation
One
Mr.
is
Simple.
based on the
applications
superconducting.
after
Which of the
applying the
following library can
Since
help
standardized
manage data sets?
framework.
The
It can
quantum
follow a
bit or the
standardized
qubit
framework
Which of the
is
following
operated
to
at the
develop
libraries can
subatomic
best
level.
help
applications
manage data
They
sets?
need to
in
be
the
maintained
particles.
at a
It is
particular
also
state.
more
So in this case, that
efficient.
we are keeping
So
at
this
this
is the
Very
superconducting
good.
purpose
state
of
at
We all know
very
the
low
that. Simple, very
temperature.
simple.
And
So
for
that
the
the
demands,
interference,
we
that
think
less
there
the
are
errors
4, I
three
must have
types.
repeated so
First
many
is
times.
the
supercomputing
AI
technology.
applications.
Sequence
IBM,
the following
Google,
data
and
people
Rigetti
steps right from the
computing
lowest to the
As I said,
from the initial
and the
step to
other
the last
concept
step.
is called what is called as
AI
trapped ion.
applications is
Sequence
focused
is you have to
on
tell me
They are
how
new
A,
to
B,
company,
C, D,
ion
E or
cube,
D, B, C,
Coney
D, A,
are
whatever.
working
make
it.
the machine
The other is a
Please answer it
topological
in that
Microsoft
way.
is
The
working
lowest
on
to
that.
the
touch or
And of course,
listening
photonic.
some
And the other
information
major company in this
outside.
area is
And
D-Wave. They're
the
using the annual.
the AI applications developing
So it is quite interesting to look at it that
expertise
now
the
people are
AI,
trying
such as
different
the
technologies.
medical diagnosis,
Because no one is
autonomous
a particular issue,
verticals with
which one
AI
is
and
the
smart
best.
factories,
So
such
because
as
it's in the developing stages, maybe over the
medical
years, we
diagnosis,
may not
for
have
example,
all
it
the
needs more
technologies to move
expertise,
forward. We may come
knowledge,
up
Anybody?
with,
because
say,
you
2 or
cannot
3
just
that is
Shanti,
best.
Ravani,
So these are the
they are
currently
sorry.
various
very expert
technological options that
recommendation
are being
of
tried
so many
by
times.
different
Must be
companies.
now in your head.
It needs the knowledge. The knowledge is the workers. However, how to
And if you look
transfer
at
the
the
knowledge. So the
basic
AI
high-level
applications
architecture of a
want
quantum
to,
computer,
more,
in some ways,
Yes,
it
Monica,
may
tell me
be
what the
similar
technologies
to
on the knowledge,
what we have in terms of
graphing, knowledge
the
in
general
general, and
architecture.
Categorizing
Right?
data.
demands on
So you
One
have
second.
the
Important
quantum
data
hardware.
set. Very good.
That's
experts
where
Then
the
from different
physical
industries,
categorizing
qubit or
data.
the
Okay.
but
quantum
no
bits
framework
are there. And then you have a
framework
quantum
uses.
processing
Very good.
unit, which
Because
is
different
consists of
industries
many
Very
qubits,
good.
and
have
then you form
different
a what
through
is called
the
as
link
quantum set.
of
Who was
them.
that?
This
We
is the
can
quantum
find the
hardware.
more
Shanti.
interesting
And then
knowledge
when
and
you
more
go up the
I thought you
next
were
higher
right.
levels,
For
then you
example,
get
this
into
is
the interfaces.
English
Then you have
documents.
a
The next
software
is
platform,
the
what you call as a quantum
I
software,
got the
Chinese
English.
and then
documents.
quantum algorithm. The
In
quantum
But I don't
software,
understand how can you
and then
categorize
find
data
between
without
these
taking care
two,
of
you have
knowledge
the
data?
interface,
And
This is a
quantum
basic
hardware,
logical
the
problem, right?
interface.
more knowledge.
Then you have
It
a
is
sort of of a
to
compiler,
You cannot do any
operating
characterization
system,
training,
which
take care
has
of all
access to
system
the
values.
quantum hardware,
Next,
and
we
then
think
you have
knowledge
Top
quantum
categorization
algorithms.
is
And
getting
meaning
dependent
this
on
is just
information.
the way in
such
which you
as
can view it,
access to the linking
because this
machine learning
helps
experts
in
with
targeting
experts from
Anyway, we are
different
your
doing
interest, where you are
industries,
interested,
such as
whether your
is
interest is in
medical,
developing a quantum
distributed
software
text.
or a quantum
transportation,
application,
and
or you
now you
are
can
interested
show
in
the
developing
transform the human knowledge
basic
to the machine knowledge.
quantum
as I
hardware.
see it.
that keeps-
And also,
This is the general
it is,
architecture.
knowledge graph
But as far as the
is
stack
very
is
important to
concerned,
count.
it is somewhat similar to
Uh,
what you have in
mistake
a
is that
traditional
we can find, we
Generating
can read
data,
the knowledge
just
graph, and
trading,
the machine
Now,
also
let
can
us
putting
read.
come to
data
the
into
It is
training.
very
quantum
clear. And
algorithm.
we
Again,
can find,
again we
oh,
have
this is a
missed
relationship
something here.
from
If you
this
have a
to
quantum
that.
computer,
We
As
can
I
just
said, when you
focus
did
on
the
the entities
splitting,
and
right?
its
but
relationships.
the hardware
This
capability
is a
do the
alone is
feature
good,
scaling
not good
data
enough.
format
on
for the
extreme,
You need to
extend,
have a
and
constraint
also
by
software
for the machine.
that can make
It is
use
sorry,
of the
extend and
capabilities,
machine is very
computational
smart and
So how
capabilities
can you have the
of
feature
very
scaling before splitting?
That's where
not
the
smart.
challenge lies as
For
well.
example,
You
in
have
the
to
So we need to
bottom,
develop
it is
extreme,
quantum
just a
algorithms
by
zero
chain
quantum
like
quantum
this.
software.
This is a very
And we
can
did the
make
feature
use
scaling
of
on extend and
the
extend. Do you remember now?
basic
structure
capabilities
and
of
knowledge
the quantum
graph
computer.
just
So
I
that
think
leads to
Yeah, so
what
the
we call
sequence
as a
should be
quantum
small data
algorithm.
set,
complex
Basically,
using
that
data,
makes use of
categorizing
the
data,
properties
treating
that we
format,
mentioned
just a
earlier,
relation
ABCD.
and so that
just
we can
entity.
exploit the
And
Now let us
the
see
machine
So
who
can
can
there are
answer this
two
one.
maybe it is
popular
very
algorithms, what is
This
known as
will
the
not
Shor's
because I have
algorithm
pretty
and
fine
Grover
the human
algorithm.
knows.
And
The
of
human
course,
can
there are
shorter
many others as well.
of the
The Shor's
information.
algorithm
And the
is
machine
Okay, I think it's
basically
visible, right?
developed
it's
for
maybe
integer
with
factorization.
enough structure.
And at that time, it was
Which of the
mainly
following
not
is not a
used for
recommended
the
strategy to take care of missing
quantum
data?
computer.
Purpose of
But
this
on
project.
a hypothetical scenario,
Great.
it
So
was
it
developed
seems that
and
there are
it is
many, industry
basically
demands,
makes use
Which
of
of the
to
following is
certain
not a
really
recommended
features
strategy
to
to
like
take
have
care of missing data?
and
standards
similarly, Grover's
that,
algorithm
What else?
is for
different
searching
experts with
unstructured
different
database
applications to talk to
or
one
not
another.
at least.
And
Yeah,
One is
for
based
that's
computer
what the
on
answer is.
society,
As I told you so
other
we
is
many times,
always want to
the last
develop
option
market
is to delete,
relevant
right?
and
And if you
high
have less
we
quality
have
amount of
standard
data,
that
so
good
that means
for
then
that
the
you'll
we
have
need
industry
more
and
quantum
good for the market
algorithms
in the
demand.
model,
that is
So
really
maybe
you'll have
can
less
you
amount of data for
tell us a
training the
little bit
model, right?
basically
more
there is a real
details
case
about the
between
use case
that
quantum
deletion is
and
kept as the
personal
last option.
you
computers.
just briefly
And
That's
as
not the
mentioned,
case
I
Joseph
mean,
between
said
the
yesterday,
quantum
from
hardware
your
and
point
that
of
if
quantum
there's a
view,
computers.
scenario
what
where
kind of
So we need
use
to
it's
develop
case
blind,
and how do we
software
not
use
able to
that
give you the
makes
your
data.
use of
standard
the
First
to
of
this
all, you
kind
have
of
to go
capabilities.
use
back to the
case?
line
Otherwise,
and get
you
the
don't
missing data.
get
It is not able to
the
give you the
real
missing data.
results.
Then you can use
We find
options like
many use
median,
cases in knowledge
mean,
graph.
or
They have been developed
mode,
So
right?
now,
Which is the
developed
most
into the
because
frequent
I
smart
know that there are
finance,
a lot of
healthcare,
researchers and
manufacturing,
developers
education,
who would like
power
to
grade,
get
and
their
transportation,
head into
retail,
the quantum
agriculture,
computing,
Question
and
number
social
how
six,
they can
networks,
have
where a
access
dummy
to
variable
quantum
is used,
and so
computer,
on.
and you
and
also
so
have
that
to tell
they
me
can
which is the
experiment
function which
and
is
get
used to do
ready
that.
for
We
the
find the
future.
Which
query
is the
of the
function to create dummy.
As you
summarization.
know
Can you
that
give me both the
probably
answers?
the quantum computer is
For
very,
us,
very
we find
expensive.
something
Yes,
to
good.
will
And it's not
recommendation
going
in
to
Right.
other
be
Tell me for
things.
question
like
number
And
seven.
also
your
we can
PC or any other
discovering related
server that
entities
you have in your enterprise anytime sooner
Question
or
number
even in the
six.
wife
future.
and who is fathers, for
So, but
example, and
nevertheless,
factual
you as a
answers.
developer
Maybe
or a
you can
researcher, as well as
directly
as a
get your
startup,
You have
answers.
to tell
can
me
have
Next,
access
the
to the
specific
context
computer
function which is used
research
following
take
maybe
the
care of
same
the
and
missing
also
principle as
the
a
recommendation
cloud computing.
appears.
So the
Next,
quantum
we can
computing offered
pass,
as a
we can
service.
through the
So almost
knowledge
all
graph
major
Anybody
cloud
speaking, please tell
service
me your name
providers
before you
obtain
speak.
the
like
full
Anybody
IBM,
writing
range
anywhere
Amazon,
of
somewhere,
Honeywell,
that we
right? So
Google,
if you are speaking,
Microsoft,
please tell me
find
your
some
name.
everyone
fraud
offers
in the
the quantum computing
relationship
as a service.
networks.
There are two
And the
things
next,
here.
the
So
converse
As you know,
simple. Come on,
knowledge graph
right?
also
quantum
get
computing
some
is still
recommendations
in
or
the
some
evolutionary stage.
results of the
It is in
converge
still nascent
with
stage.
the
Question number
It's not
6.
patterns
mature enough.
and also the clinical
And
trials
so when
and
they offer a
other
quantum as a
statistics
service, there
analysis.
are two
And
options.
then
One is that
in the
the
manufacturing, we
simulated
can
quantum
to use
computer
the
that is
knowledge
offered
graph
an
to
option on the
explain
cloud.
reason and
That is one
biases
What happened, Monica,
Other
behind the
Jamila,
some
Shravani, they all
AI-generated findings
say
because we
cloud
can
service
Jamila is
we
saying
can
A.
make it more
link you
Okay, if you
to
didn't
the
say what is the
infrastructure,
function,
the
the
users of
quantum
the knowledge
computing,
graph,
say by
including the knowledge graph
some of the
suppliers,
major
what is the
quantum
function to
computing
create?
creators, users,
So
and
you have
also
access
some
to quantum
partners,
computer
ecosystem
quantum
partners
computing
such
as a
as
service
data
model,
provider,
so that
infrastructure
you can
provider,
work on it.
and
And there are two
consulting
options
somebody was thinking.
and the testing and
work on a
examination and
simulated
answers,
quantum
and
computer
also
so
the
that you can
knowledge
start developing
regulators.
the
Ma'am, can you mute this person,
software
please?
Because
that
we
makes use
we
of
may
capabilities
touch
or the
the data
nexus of
privacy
inherent
requirements from the government
potential
and
of
ఏ
the
మరీ
computer.
దారుణంగా అసలు ఇది.
next the
Or
గని వాళ్ళకి
safety and
release
security
extent,
of
you
its
can also
29
have
ఆహాలు
we
వచ్చేస్తాయి.
access
can
to
do
Ma'am,
some
ma'am,
restrictions
can you
on
please
the
mute this person?
safety and security.
So this is the way
Thank you.
where the lot of
Okay,
developers
great.
Yeah,
So
data
we
category
will
is
cover
correct. We
different
have to tell you
kinds
which is the
of
function.
users in
License
different
you can
domains,
get
and
access to, like
you just
using a
mentioned
quantum
Take care of
about
that
computer,
vertical
you can use a
applications. So I
quantum
believe
computer
actually
as a
for your
service.
standard, you really cover many different
And
kinds
in
of
order to
Can't we error
develop the
you?
areas.
tools,
Just
although
like what
the
you
hardware
mentioned
still
about the
under revolutionary
10,
phase,
10 different use
now
cases at the
major
beginning,
developers,
So,
quantum computing
and I
developers
understand,
know
you
that
know,
just
for
hardware
your working
development
group
alone is
in
not
the
good enough.
computer
There
society,
need to be accompanying
Yeah, you
software
talk of
development.
get
actually,
dummies anyway.
So they are providing
P20X07 is
software
only one
development
of the
kits,
many standards you
IBM,
consider
good,
But I
because
never
they
talked about
offer
get
it.
dummies function
So
anytime.
for
depending upon your interest,
20X07 is
you
not
can
a
get into one
framework.
of them,
And
get to know
actually,
about
under
the
the
We
different
talked about
framework,
one
software
hot
you
encoder,
have
right,
lots
guys?
of
So
different
that is
kinds
why
of
quantum
and one hot
computing
standards
tools are
that you are
available,
also
RSA.
So the one
developing in
hot
your
encoder
working group.
function was used
So,
to
and I
So
also
now,
dummy
actually
let us
see a
turn our
question from one
attention
of the
to the
audience. What is the
application here.
we had
status
to
of
create an
the
So
array
far
of
we looked at
dummy
the
variables.
basics of
So,
Array of
quantum
Richie,
computing
TLS, right?
actually,
and
can
what are
you
the
One
various
value
share
had
with us
one,
more
others had
about,
0.
techniques
So
or
that we
various
call it
what
as
is the
sparse
current
matrix.
status of the
and
of your
then
job
the
Right,
need
right.
for a
Okay.
quantum software
and
and
what's
how
the
Question number
we can have
seven.
an access to
Which
it.
are the Python
projects
libraries?
that
Now, why
your
there are a
working
lot of
group is
interest
focused
in
on,
quantum computing is
on
that
relate to knowledge graph?
there are many kinds of problems that
Okay,
cannot be solved by
thank you.
current computers, that I said. They are called quantum
Hence, I
advantage
think current
computational
standards
problems.
of the P2807,
What is quantum
the
advantage
content
is
of
that
the draft has
those are
been
the
frozen
problems that are
in our
better
working
solved
group, and also
by a quantum computer.
ballot
So
pool
that's what
will be
quantum advantage
established
computational
before the
problems.
March
Basically, there are four
in this
kinds of
month.
problems
So we will
that are better
go to the next
suited
steps
for
from our working group.
addressing
Anybody
the
else?
quantum
And
computer.
I think there are
One is,
also
as I
some
mentioned earlier,
standards is
the
developed to be
computational
developed in the
optimization
next
problems.
steps.
Optimization
For
of any
example,
kind you
point
take it,
one
then
is
that's
standard
whether it's in
for
the finance
technical
sector or in
requirements
the
and
manufacturing
Yeah,
evaluation
or
NumPy is
logistics.
and the point four
Or any
sklearn
kind
is
of
scikit-learn,
related
yes.
problems.
Scikit-learn, if you
for
have seen
The other is
data
scientific
pre-processing
knowledge graph,
differential
and the point
equations.
five for the
It has
medical
used in many, many
fluid
cases,
flow
right? For example,
this
data
is
and the
plane,
other things,
limit
fluid
the
flow
encoder, hot
simulation,
encoder, we
project.
use
that's
We
another
will,
area.
we will
And the
develop
linear
in the
Matplotlib,
next
yes.
machine
How
learning
can we miss Matplotlib?
and
this
those
MATLAB,
kind of
yes.
this
next
risk
year.
All the above.
estimation
And
in the
also,
in the
all the above,
finance,
that is point
DNA
number.
identifying
sequencing,
some
classification, those
very
kind of.
important topics.
Okay,
And of course,
question number 8. Which
factorization
class is used for
want
in the area
categorizing
of
data?
cryptography
apply to
and other.
standards.
So these are generally
project
these
from
four kinds of
IC
problems
and
is
from
called
Metric.
quantum advantage
The point
computational
7
problems.
is about
They are
the
better
open
suited
domain
for
knowledge graph publishing
addressing
and
this problem.
Which
crowding
class
service.
is used for
This is a
categorizing data?
guide
So that I
because
said, I
maybe
need to
some knowledge
emphasize
graph
that
will be
the
open
quantum
source and
computer is not
published
going
on
to
the
replace
network.
the
So
traditional
how
computer.
they need
We'll
some
still be using
publishing
quantum
and
computers,
crowd
traditional computers,
sourcing
and there
service
will be
on
your
this
further
knowledge graph.
developments
So
in this
we
area, although
Question
it
number
will
we
be
8,
can
limited
get
in
some
nature.
times for
8,
So
9
we'll be
yet.
and
using
the
these
next
traditional
is the
stuff.
8
We are
is
not
the
going
NP,
to have
correct.
which
a
is
quantum
the
computer on
standard
your
for
class,
knowledge exchanging
on your desktop.
Linear
and
regression, how
knowledge
it comes
fusion
under
quantum
among
categorizing
computer
linear
is
regression,
best
we know
it is
for
talk
we
to
can
suited
skill,
develop
for
right? It is
solving
label
some kind
encoder
of
and
problems.
one hot
others
encoder.
And that's where we will be
Fine.
using the
Let us see.
quantum
Question
computer.
number 9. Which is the
So still
recommended
we
ratio
are
for
using the
splitting
traditional
data
computer.
between
We
M7
are
and
not
DSN?
going to replace that.
then
And in
knowledge
some
Eight is
cases,
A and B,
we'll be
B and
using
C,
some
okay?
both
information
quantum
or
computing
share some
Fine. What is
knowledge.
the, what is
But
9?
we think they
So
need
the
a
quantum
project.
computing,
So
just
this
let me
is
give
our
an example of
project.
various
Also, I want to say, if you
say,
are
attention being
interested
paid
on this
in the
project,
application of quantum
please contact
One
me.
is the drug development.
And to the bottom
In the
is
new
my
drug
email.
development, a lot of simulations has to be
Also,
done. And that is
80-20.
one area.
Yeah,
that
please
is
continue.
where
Sorry,
the
I just
quantum
say great.
computing- Other is the financial market.
Is that the
next,
only option?
All kinds of modeling.
we see
So
this is
the
a
risk optimization
standard
and
system
the
of
portfolio
knowledge graph.
optimization,
So we
which
give a
stocks to be
framework.
bought on this one.
We
And
I see.
deal
there
with
are
the
other,
discussion.
many other
70-30 is the
areas. The
minimum.
financial
Which
sector
standards
is very
need to
key
But
be
it's not
developed
necessarily
in
the
on
only
using
one.
the quantum
or
computer. In
how
fact,
we
But I
can,
agree.
many of the
Minimum
top
70 and
financial
30, right?
institutions
But it's not the
are
only
in
option.
some
Only
ways
option.
collaborating with either the research
So 70-30 is fine.
or
30-70
quantum
obviously
computing
you cannot have. You
manufacturing
cannot have three
standards
integrations
for
in
the
the
and
concept,
some
right?
digital
And other is
infrastructure,
the
80-20 is
and
also
some
fine.
As you all know, that
100-0
battery
basic
is
never,
the
development,
you cannot have zero. You cannot have
main
zero.
component
knowledge
How
of
is
many of the
tours
devices
and
now we
knowledge
use.
reasoning tours,
So
So
reasoning
now
you
tours,
need to have a
including the
test.
autonomous
and
cars,
90-10
and
also is a possibility.
battery
technology
operated cars
standards
and
about
things like
Wherever
that.
you have large
Better
volume data sets,
batteries.
you can also
So
use
many
acquisition
companies
and
are
others.
making. And other is the fertilizer.
And
So 70-30,
under
80-20.
we find
Manufacture
the
fertilizer,
agricultural
which
service
uses the
standards
ammonia
and
as a basic
Okay,
component.
now-
some detailed
So now we are moving towards
get out
what is
of
called
this.
the
And now
domain
clean
let's
or
go back
green
to
standards
fertilization,
is
our
also
theory.
and
very
say
important,
coming
such
up
as
with
the
the
So we
new
covered
fertilizers
beta 3
0.5
processing
and
on
that provide a
72.
better,
Same will to
say,
address
minimal
the
impact on the environment.
standardization demands.
Those are the
Regression,
areas,
as I've
traffic
told you,
optimization, weather
you
forecasting.
had a
And
univariate
interestingly,
multivariate
AI also is
regression.
another area
container
about
safety
the
and security is very
dependent and
important
independent variable.
computing
You talked about
be exploited,
implementation of a
and
straight line.
for
very,
capture
There are
materials,
various,
smart materials.
information
regression
Because
types.
now there is a lot of interest
So you have
in,
simple regression,
minimizing
multilinear regression,
the environmental
polynomial,
impact
multi-vector,
of some of the materials
So today
used during the
we will
manufacture.
focus on simple
Now
and
how we
multiple.
can
There are other
promote the new
regressions.
smart
This is our
materials.
framework.
So basically the
And what
material
the concept
discovery,
is more or less
those are
the
the
same.
areas.
I will
Based on my
focus on
understanding
simple
from
and
what
multiple
you share with us,
And I will also
it
tell you
seems
how to
that
measure
first
the
of
accuracy
all,
of
you
a
actually
regression model.
identify
Lot of
an
interest.
opportunity from the
Because we are
industry,
trying to
from the
address
market demand
some
that
of the key
there's no
problems
existing
Now,
knowledge
pay
that could not
attention
be
to
framework
this
solved
slide.
by the
standard.
conventional
So that's
computer.
why
So
you
now
want to
You
there is
remember,
a potential
I
for
have taken
using a
one
quantum
example
computer.
of
So
years of
everybody is
experience and salary.
express from
not only
different
the
Was the
businesses,
regression
applications.
but
data,
also
With
the
these
where
government
the
AI
aspect.
salary
applications
was
can
the
work
Because
together.
dependent
with quantum
And then
computing,
under
variable.
this
now
framework,
is
you
seen as a
identify different
strategic technology. So everyone
explicit
want to
Now,
do not
opportunities
imagine that
want
obviously
to
for,
lag behind
regression.
the
for example,
technology.
just
That's
So
why
when we
you
have
have
talked about
the
involved
national
regression, that
X0771
we
strategies or
had
to
policies.
really
a training
Almost
set and a
every
test set.
major
have an understanding to
country
talk
And then the
about
has
training set
technical
was used
requirements,
quantum
you know,
initiative
for
train
the
the model
knowledge graph.
so that the
And
model
you also
will
have
be
some
able to
other
come out with
standards
some
that
pattern
what
as well as
or
focus
a correlation
particularly
between
on
the independent
applications,
variables
right?
and dependent
and
So
variables.
now
China,
the medical
they have their
applications,
own quantum
and
computing
When
strategy
also the
and how
scientific
they want to
knowledge
do
graph
the
like the check
and a lot of
model
support is
evaluation
also
and
being
the
provided
five.
by the
when
So
we
government.
it's
had
really great. So
inputted the
you
independent
you and your
variables,
having
working
said
group
that,
really
okay,
understand
into the
you know,
model,
the
in the
industry
interest
of
of
the
came out with
time,
knowledge
the
club and what
predicted
you
Y.
want
so
to
I'll
do
just
Predicted
to
say
have
salary.
an
that
industry
the
Okay, came out
applications
with the
work
predicted
are
together.
salary.
quite
Now
varied.
this
And
line
this is
that
the
you
I
see
also
pharmaceutical,
believe,
chemical,
you know,
finance,
it's already
transportation,
is the
airlines,
you
predicted
know,
line.
and
you
That
oil
means
and
already
natural
if
companies
understand
once
also
I
and
have come out with a predicted
get
salary
many
having
for
said
information
that,
from you
from the
about
test
what
data
knowledge graph
by
standard is and also what your working
now
group is
let us look
doing
at
for
input
the
data with the
society
experience
and you
which
know
is this,
for
this
general
is
IEEE.
how
broad area
So
of
the predicted line will
applications.
look.
There are many
and
That
you
areas
know
means
it's
where
for
almost also
each
it
years of
gets
close
experience
to
you
the
have
end of
a
our
predicted
webinar. But
now
I
salary.
just
let
That
us
is
look
the
at the
I
other
mentioned
side
at
of
the
the
why
coin.
very
I
beginning
carry.
of the webinar,
This is a
not many
representation
Now
of
for
us
we
usually
have,
do
predicted
course
suppose assuming
salary
today,
that
you
from
you
know,
the
have a
test data.
quantum
understand
computer
how standard work
And
that
this
and
is
why
YI
capable
standards
is
of,
the
bring us
actual
I would
value.
say,
test
a
data.
lot
So
more
from
So
your
you
capable.
had
point
the
of
actual
view, you
test
know,
data,
Then
based on
which
your
you did
is there any
extensive
you
risk
did the
that
experience and participation
model evaluation, because what we
national
did,
and
we took the
international
if on
independent
standards,
the other
variable,
hand,
what's the
there
lesson
based on
learned?
say
the
highly
What's
powerful quantum
training
computer
I
that
mean,
the
what's the
model
can
has gone
easily
experience
through,
you
it
have
had come out with
learned
some
from
pattern,
but
your
what we are
and
more
seeing
based
so
on
than
that,
10
far
the
years
model has
is
predicted
experience
that
the
in
output
all
or
standard
the
uses
independent
for the
variable.
participation? Is
That
there
is
low-level
YI.
anything that you
application.
could share with us,
Now
And
there
please?
is some
YI is
potential
your
risk as well
actual
that people
test.
talk about when
Okay.
they
That is
talk about
output
quantum
of
computer
independent
Thanks.
is the
variable.
risk.
I think maybe
So if you
So
see
where
I
here,
quantum
also
these are
computer
dots
can
here,
be made
very
use
which
of
is your
important and
actual test data,
to
this
break the
and
gives
code
this
some
is the
helps and
on
predicted
which
line,
tricks
that now
my
which
all
is a
our
Y
security
through
systems
the
are built.
So this is the Y
So
character.
that
standardization
is
of the
one
knowledge
concern.
graph.
Now, in
But
order
currently there is
for my
not
regression model
much,
to be
so
effective,
we don't have
I
enough
find
we all
of it.
discussed
through
that
the
So
your
we are not
accuracy should be
standardization
high, your
development,
So
YI
we are not,
and
I
Y
we don't
think
caret
have
I
should
have
be
quantum
more
computer. We are
understanding
not
of
likely to
knowledge
have it
independent
in
graph and
the
variable
its
should
say
be
next to
importance
5 to
and
10
close to
years
the
its
that
development,
can break
future,
the
and
security
That means
systems
in
its
order to do that, the
standardization.
distance
But in
between
the
this
future,
And
YI
if
and
it is
next,
Y
I
cap
possible,
think
should be minimal.
then there
That
is a
through
means it
this
should
possibility
be
that
experience,
close to
I have
the
more
someone would make
understanding
use
on
of
the
the
pattern
computational
IEEE
capability of quantum
standards
to break
development
some of the
progress.
If
I
you
have
take
more
YI
say,
and
security
familiar
Y,
from
YI
the
minus Y caret
approval
computing
the whole
or
square,
communication
to
security makers
sum of
have.
that,
That is the one
ballot
risk.
okay?
to
So to
publish.
In
address
order
that,
for the model to be
people are
efficient,
looking
YI
at
accuracy
what
and
is
Y
called
caret
as
has to be
process.
close.
post-quantum
YI
And
minus
computing.
Y caret
next,
the
I
whole
So
think
square
that's
has
what
to
I
be
it
want
is
to
20.
most
mainly
important.
focus on.
We
So that
can
it
And
might
this
be of interest to
function
some of the
uh,
researchers.
or
is called
What is
establish
the
the
post-quantum
tenable
cryptography is that
to make different
commercial
engineers
also
cryptography
refer
or
it
diplomat
as the
is
institutes
mean
developed
square
or
error.
assuming that the
universities
code is
Okay.
hard to
together.
take it as a
So,
computer
maybe
power
they are
if your
is
regression
much
model has
smaller
to be
than what
effective,
is needed to
during
break
the
this particular
non-graph
regression model, this
standard
What
particular
is the
cost
first
function
part of
development
cryptography is
because
that
minimum.
they can
development
communicate
of
with
new
others.
So
They find,
how
oh, this
cryptography
a
is a
regression
techniques
good
model
idea.
works
I
is
can
that
apply
your
that are hard to
coefficients
break
which
my
are there
even
researchers
with
is
or to
adjusted
my
in such a
So
way
that's
professor.
what the
We
post-quantum
can
that
cryptography
cooperate
is.
your yi
with
minus
there
y
are
caret the
develop
whole
two different
square is
approaches.
project
minimum.
is called a
For
quantum
a user,
resistant algorithm.
So,
or maybe a
In
user
order
find
for
out
regression
very
model to be
quick
effective,
How to
like
make
always remember
this
your
is
cost
a
function
platform. I think
or the mean
communication
square area
quantum
has to be at
algorithms
minimum, and that's where
I think
resistant
it
to
is
that.
very
theta 0 and
interesting.
theta 1,
Also,
which are the
other reason
coefficients
you
are adjusted in
communicate
such a way
others
so
and
as to
obtain more
obtain the
knowledge from
minimum
them
cryptographic
sharing.
technique.
And
or
next,
to
I think
minimize.
joint
So that is
discussion,
one
joint
area of
Is this
discussion
clear to all?
between
So
What I
just
talked
I
about?
want to
standards
bring
is
to
Have you understood the concept of
So
y
there are
caret
other
and
areas
y?
from
of
different
interest as well, what is called
stakeholders.
as a quantum
We
AI,
join
meaning
discussion.
that
Maybe you
application
have
of,
positive.
say,
Can I get a quick
AI
yes
machine
on the
learning
screen?
using
We
the
can
Have you guys
quantum
understood?
computer,
we can discussion.
so that
And,
it can go
then
much more
we
Everybody?
deeper, much
oh,
more
this is
extensively.
common things.
And the
And,
post-quantum
we just,
cryptography I mentioned
okay.
there.
decide,
And also someone
we
also
So now
used
let's
to
go
do
back
what's called
make it
quantum
and
music
into our
using
draft
quantum computer
and
Yes,
to
to compose
this is
music
our
and so on.
consensus.
So
I think
let me
this is
close
very
this.
interesting.
So
I
that's
already
all
know
good,
that
but where do you
I
stand?
did this
Yeah,
as
there are
a
many
As I said
guidance
there,
important
I've got that
we
guidance.
are
spider
at
again.
a
How I
very
see it.
Now
nascent
I'm in a
stage,
simple
And I see
derivation
and
mode, as I
there's
told
still
you.
long ways
When I
to
give you
go
my
make
data
the
set to
good
you,
quantum
experience
you
to
will
share
have
me, and
reliable,
I can
stable,
follow
and
your
also
as I
guidance
told you, you will
is,
have
to make
currently
me
quantum
to
systems are
a data
dragged,
driven
further.
regression
as I
And
and
mentioned
since
there. They
I
have been
think
So
kept
I'm
in
now
a
going to the regression
situation
folder,
development,
simple
and a
regression
large scale
folder,
environment.
development,
And of course,
we,
there are
we
also
have
needed
to
and I
concentrate
say
platform for
select
software
folder.
development
energy
Okay?
cost
And in the
hardware
files, I
development.
will
As I
see a
said,
number
they
of
need to be
just
much
drafting
data
further
files
go
and
ahead.
Python.
So we
discussion
are
and
in the
decision
early stage.
So
consensus
my
is most
data set
important.
is
Nevertheless,
This is
the one
because
already
of the
talked about
potential of
user
quantum
experience
defined on
traveling
the
with the
draft,
univariate
but
regression.
it is
and a lot of
And this
people
is
are
my
interested,
secret.
both for
Force and
researchers,
energy.
businesses,
Well,
and also
others are
be
interested.
patient on the balance of works and the standard development.
So in
maybe
summary,
some experts have
although it is
works
nebulous
on
concept,
other
it is
things.
time to
Maybe
be
he
aware
is
of
just
and examine its near and long-term
product
Now-
potential.
developer, but he
And,
must have to
let us
realize the
go.
quantum
get
When I
advantage
give this
time
data,
to discuss
I know
with
the
some
problem
other
But of
statement. I
course,
need to come up with
realizing
the
the
model as a
quantum
data
advantage
set.
of the
So I
clear.
know
quantum
I have got
computer
four
is
stages:
quite a
data
challenge.
preparation phase,
But
data
nevertheless,
modeling,
the major
creating the model
translation
phase,
researchers
model
and
evaluation
even
phase with the test data,
startups are
and then
working on
This is
that.
my helps and
And
deploy
so
the
quantum
deploying the
computing
model as a
is in
standard.
a sort of
The
very
first step,
evolutionary path,
let's go
and
one by one.
rapid
Data
developments is taking
Great.
place.
Okay.
So it seems
of
to
course,
be
first
that
important
not
thing,
only
what I'm
in
going
new
to do
directions.
you
So it's
you and
totally
your working
entirely
I
group
will
new
members
import the
need to
area
have
and
strong
new thing.
technical
So
knowledge,
we need
but
to
also
work
throughout the
and develop
standardization process, you and your working group
So
members
I
also
mentioned
learn
that
and
earlier.
also
There
use
are
many
5
soft
one
important
skills that
anniversaries
is
I
good in the
mentioned
together.
career.
before.
You know,
And
like
then
the
I am
First is
using
negotiation
the
this.
skill and
computer,
communication skill.
relatively
And
75th
also, you know,
My data
anniversary.
set
lots of
is
So
effort and
it's
energy,
good.
as you mentioned,
And
because
Yeah.
it may
And
be
obviously
a
I
work that lasts for
don't
more
see
than a
any
year,
And the other
and
one
sometimes
is
it's
Between
even
the
2
22
years
one
to
last year
have a
was
so
the
I don't have to
40th
make any
anniversary
border.
of
So I
It's very
quantum
great.
computing, if you want to
which
call
is
it.
my
So
user
now, you know,
experience.
It is
we
when
only have
the
about
my
5
concept
minutes
of
now,
using
so this
the
is the
quantum
Q&A
mechanics for
time.
computation
And you
purpose
know,
was
as God
proposed
mentioned at
in
the
a workshop
beginning,
that is
for
40
anyone
years
who
ago.
joined the call today,
Now, do you
Though
need
it
to
was
do
40
data
years
type
ago,
in
categorization
it
the
was
here?
proposed,
chat box,
Do you need to do
and
so
data
that
for a
you know,
long
categorization here
time
for this
there was
data?
we
not
will
much
see
of
what kind
keen
of
interest in it.
questions
Only
you may
in the
want
last,
Yes or no?
say, 10
Richie
to
to
15
answer.
years,
And
there is a
actually,
research
so far I
in
see a
interest
few
in quantum
questions,
computing.
Right?
lots of questions already. So Richie,
So with that,
there is a question
the
from
thing is
Mark
that
who want to
the basic
know
principle of quantum
um,
mechanics
rather
Very
the
good. So you don't have any
feel
text.
that,
P2X0
feel
job
that
is
it's
available,
counterintuitive
and
to
if
Since you don't
available,
have text
where
data, you don't
shall
have
we
to do
get
any
it?
data
but
Do
that
you
is
have
okay.
any information on
Okay.
that?
Because that is
Whatever
the
the next
nature
step.
of the topic.
Do you need
This
to
is
do
a
You
very
understand
the data
quantum
into taking
computing.
into test?
question. I
And
think
also
maybe it is
simultaneously
not
think you don't understand it, that's
wide
okay.
available for
And in
everyone.
many ways
It
it
Take the
is
matches
data into
the
training and
quantum
test set.
on
mechanical
Yes or no?
level and
principles.
working group level.
But
I think
nevertheless,
You have to
you
do
don't have to
that
be
is
a
no
quantum
option.
physicist
we
You always
work
have
with
to
quantum
do other
computers.
things. You
You
cannot
can,
do
as I
like
said,
Luckily,
that you
and
can work at the
how
different
do you
stacks
test the
with
model
quantum
the
if you
computing,
without the
we
test
need
data?
to
You need to
can
have
be
this. Very good.
published
You need to do do
through
feature scaling?
our
So on one
IEEE
hand,
in this year. Maybe
we
it
will
is
be
just
having
our
sooner
plan to make it
or later a
quickly
quantum computing
Do you need to do
much
feature
more
scaling?
available
developed.
and readable
But
for
is
each
it up
one
to us
at work.
how we want to
Yes,
make this
Okay,
right?
so
Because
that's
the
me
user
now
is
to
used to salary
how
to
we want to make
answer
this
my
something
question.
good.
What you say is
It's up
that
to
So now
us
we
right
know the
now
data preparation
the
steps.
standard
So
is
good.
under
As
development,
So I've done
and
this.
so that's
Now I'm
why
going to
it
read
is
the
only
data. So there are
available
10, 30
among
records.
you
For
to
simplicity, what I'm
participate.
going to do,
So if,
Yeah.
for
I'm going to
example, if
put this
system
Mark
with
want
which
to
we use
have the
10
job,
records of test
one
set
of the
and 20
quickest
records
way
of
for him
training
is
set.
to
So
join your
one-third
working
and
group
one-third.
to participate,
Okay.
so that
So I
they
got
know
X-train, X-test,
he
Y-test.
can have more
there
information
is a lot
about
of
your
Now,
job,
good
the
or
articles
mod,
otherwise,
the algorithm that I'm
he
going
may
to
need
use
to
is called a
wait
linear regression
maybe
algorithm.
about
And
half a year
say,
linear
until
regression
you know
algorithm
you
by
finish
itself
the ballot
takes
from
care
the
of
Standardization
quantum
Association
computing.
and then have the job
And I
published
would
in
like to
If the
IEEE
highlight
algorithm
Scholar,
does
right?
take care of
2 or
feature
3
scaling,
Yeah,
I don't have to
thank you.
explicitly
Yeah.
write any
articles
I
code.
see.
that is quantum
Okay.
computing. Yeah,
And
I don't
then
have
I
to
see
explicitly
another
write in code. That is why if you
question
see
from the link. I'm
Those are
sorry
I
if
would
I
have
pronounce
completed.
his or her
And the
name
IEEE software,
incorrectly. But
the
Please
publication of the
understand
the
that
question
IEEE
is,
in the industry,
do
they
you
published
follow
last
existing
year,
thing you should
standards?
quantum
remember.
computing.
Why there is a need for
Every
new
company
editorial
standards?
has their
article,
own
very good
So
own
article.
can we
standard.
And
So
then
answer
you
this
should
question
there is
adhere to
also?
that
one paper
standard.
that is
That's
the
the
open
objective.
access
So
query
And
set.
because
secondly,
We
you
have
should
you
do
a
mentioned
proper
maybe we don't have
documentation
any
of the code.
existing
quantum
standards,
Whatever you
so
are
you may
writing,
There
want
is a
to
paper called
share
Quantum
with us
Computing
more
because you are
information.
writing this code not
State
for
of
yourself,
Art
but
and
for your
This is
organization.
very good
Or
Isn't
for
it?
if you are an
and
entrepreneur
interesting.
or
And
also,
there are
somebody,
a
you are
few
writing
others
code
as
for
well,
your
but that
own
will give
company.
you a good start with.
Yeah,
So you have to
as-
ensure
as,
that you have to
this,
write a
So
code
with
in
that,
such a way to
just,
document each and every
I
line
would
we
to
have
explain
say
what it
thank
is
you to
doing.
you all
Because
for
tomorrow if
patient
some new
listening.
person comes,
And
or
as
you go on leave,
very
you
good
get a
said,
company, somebody
we
comes
can
and
take
gives
a
you
few
your
insights
notes for you.
RDF,
time
or
available.
RDF standards.
That is
very
that
important.
is
The
a
standard
whole
Well,
mark
thank you
of
very much. It was a great presentation.
Also
We do
follows
have a
the
few
program
questions
standards,
already in the
on
Q&A
the
if
knowledge,
anybody else would like to put
So
their
here I'm
presentation
interested
there.
that
knowledge,
linear regression
we
algorithm
would be
takes
happy
care
to
of
take
feature
them.
scaling.
Let
That is
me
why I
go
don't
to
have
the first
to
one
comment.
here.
knowledge graph.
Sorry, I have
Says,
submitted
thanks
try
for
to
the
submit
presentation.
immediately.
So
We need the
essentially,
knowledge
quantum computing is doing
knowledge
the job much faster.
Now the next
Is
thing
there
I do
anything
is
that's
training
not
of the model. So
possible
what do I
through
do?
traditional
I
computing,
treat
is
the
also
but
very
dependent
quantum
important
computing is
variable
making it
training set,
possible?
and this
independent variable, and
and
Yes,
this
training
as I
set
standard
mentioned
independent
will
in
not
the
get
later part of the
I
lecture,
use the linear
there
regression
are many
algorithm
problems
or
that
class
the current
thus we
traditional
get
computers
the
cannot
out
solve.
with the
standards
pattern.
on knowledge
And the
graph.
quantum
And also
computers
This
can
is what
solve
it
it.
does.
maybe they
All
are
kinds of
not
optimizations, some of the
the
I'm
optimization
feeding the
problems
training data into
and
using linear
standards
regression
on
algorithm
simulation problems
and using the
So
that I
algorithm I'm trying
highlighted
to
in
come
the
out with a pattern between
lecture.
purpose of
Yes,
the
the
years
there
of
are
project.
problems.
experience and
That's
as a
why there is a lot of
project.
interest in the quantum
Edward.
computing. There are
Then if you
problems,
remember what I
great.
said,
So
I
again,
take the
you
test
identify
data
a
X
marketing
test,
and
which is
keep
my independent
the demand
variable,
that there's
feed it
no
into the
existing
model
jobs. So
and
that's
come out
why
with a
I need
white
existing
thread,
standard
white
on
carriage.
knowledge
This
graph.
is the one which I
So
explained
that's
to you in
why
the
you
next
question
propose
we
in
have
Computer
is how
Society
long
and
does it
Standard
take for
Association to
quantum
Now
start
this
the
white
knowledge
thread,
graph projects.
to
I will
fail,
compare
And
it
then
what?
I
especially
see a
if
question from
the
Thomas
simulation
to
and
actually
White
ask
thread,
has any
I will
work
compare
start
with
on
which
members
variable?
of the series. So you
Can you
know,
repeat the
you
question?
mentioned
White thread,
before
I will
you
compare with which
I'd be
variable?
happy
push to
to.
the slide
It says
here.
how
You
long
mentioned
does
before
it
you
take
have
How
different
will I
kinds
know
of
my
standards.
effectiveness
computing
of the
So
model?
algorithms
maybe
to
Thomas want to
fail,
know, what's the
especially
status
White
of
test, I will
simulation
compare
and
with
Doc
what?
iteration
1, Doc
problems?
4, and Doc 5,
Sorry,
and
white
Doc
thread,
7,
white
and
thread,
Doc
sorry.
8. Can
White
you
thread I will
briefly
compare with
talk
what?
about
I'm
what's
not
the
clear
current
about the
status?
question, but
About
as I
this
said, there are
FMD?
still barriers in the quantum
Yes, Shanti,
computers,
come on.
and the quantum computing is
the point
the
one,
Yeah,
facing
Shanti.
big problems
point
due to
five
Shanti,
is
noise
approval.
and the
And
stability
the
problems
point one, we have
that
developed
will give
This is the
some
basic thing you
relevant
guys should know.
issue
and
of
we
the
have
quantum
I explained you the
computing
workflow so many
beyond
times.
that. So I don't have any specific answer to this question.
White thread, you will
And
compare with
point
which variable?
four, we
Very
have
good.
developed for
The
half a
next
year.
question is, one second, this one's a
And
longer
we
question.
also have the
It says,
outline
thank you,
and,
Professor, for your time. Could you
draft of
please
some
throw some
Shanti,
light
answer.
on the
we
impact of
just
quantum
Can you
computing
please
the
repeat the question?
future cybersecurity?
I have
and
calculated.
proposed
I have calculated
We're
white thread. You got
hosting
this
work
point,
on
right?
quantum
I had
resilience
inputted
month
X
for
test
futuristic
into the
cybersecurity.
model and came
the
out with the
point
white
most
predicted
important
salary.
The
and point eight,
nature-inspired
just on
cybersecurity
the-
Did you understand? Did you guys understand this step?
to
Yeah,
it.
application
Okay,
Share
sir.
your views. sir.
establishing of
Actually, I'm
projection.
going
Now that you have got a
This is
widespread,
standards.
with which variable you are going to
along,
compare to find the
and
effectiveness
Okay,
of the
great.
model?
So it's
White
so
range,
based
sir.
on the information
White?
White
we
test
get
it.
from you. So
Y test, yes.
X07
Very good.
is
Because your Y
very
test is your
mature,
actual
is
test
close to
data.
propagation, maybe in a few months.
And your widespread is a
for
predicted
Chinese
data.
X07
So you have to
is a
compare
good
widespread
question.
and
0.4 and
When is
0.5.
that? There
Just
is
You are
try to
still
concern that
working with your working group to do that, and
when,
there are
if
still
and when,
opportunities
if a quantum
for
computer reaches a
newcomers to
stage
contribute.
that is
And
stable,
then for
and then a higher number of bits, we reach a
20X07,
higher number of
0.7,
bits,
and
we
0.8,
still
they are still
cannot
under
reach the
the
stage
approval from from
that
standard
which
association
you
before
can
you
Now
form
having
the
done that,
break
right?
so what is the
current
way you
yeah,
can test it? I can
security measures.
Okay,
open
great.
Whitebread.
But
Okay,
there
so
is a
it's
potential.
almost the end of
I
our
can double click Whitebread.
Maybe after 10
time.
years or
So
15
just
years.
want
So there is
all
a
of you know
potential
that
do some
that
sort of
if you
visual
want to
quantum
know more
computing,
information
if and
from
when
the working
I can
group
do a
reaches a
visual
stage,
summary.
it
is
breaks this
leading,
one,
you
then
could
we
go
need
to
to
And-
have
the
other
2807
So,
website
for example,
that
here
we
if I
provide
see,
here.
people
And
are
as
what
Scott
that's why
mentioned at the
researchers
researchers are
data, right?
beginning,
So
we will
on,
share
as I
just now
said,
before.
as
see
the
here,
speaker
after
is
And then,
attended
saying,
you
call,
know, in
the
our
question is
where
to
my
say,
actual value
people
is
are
also
working on
have technical
37,731.
committee
The
on
model has
data
predicted
quantum
40,000.
resilient
and also we also have one of our
as well as the
Here it is
cryptography,
122,
applications,
this is
as well as
which is the
123.
the nature
transactional knowledge and
inspired
data engineering.
Very,
security,
very
That
as well
good.
as
you could
nature
Not bad.
also
inspired
any
57 and
latest
is gaining
65,
some more
quite
interest,
relate to
taking
AI
the
and
insights
knowledge
from
63 and
graph.
nature.
And you
63.
Yes, those
also,
Not
are
if
bad.
the
you have
areas
charm,
that
please
are of
also
116,
take a look at the
115, not bad.
latest
started
issues
working
of
on
our
that.
flagship
1081,
So it's a good
publications.
area
I
to
mean
work
the
108126,
computer and also computing
10943.
although
edge,
there is no
because
Quite a
the
immediate
current
danger of,
issues
to the
about
security
AI and
because of the
software.
quantum computing.
So
64,
if
There
you
is
are
a
very
potential.
interested in AI and
So,
knowledge club,
as
take a
This is
look
one
at
way to
our
calculate.
magazines
they
and
look
understand
And
more
122,
about
obviously, this
what
is not the
our
most
try to
society is
address the
doing.
problems
realistic way
and
because
So
you could
Scott,
have
I
thousands
think
of records, but I'm just,
we
as an
share
example, wanted to show
all
you.
of the
Very
different
good.
kind of
This
high
next
level
question
How do you
information
compare?
on the
So this is
standards
the way
and
to
also
sort of
there's
compare.
807
that
already.
The other way
So
to
maybe
compare
I
it,
give back the platform to you
I use-
Do you have any views on
Barbara,
that?
metrics.
Scott.
Yes, it is error prone,
Awesome.
and
Thank
currently
you,
some of the hardware is
Edward
unstable.
and Dr.
So
Lee.
that's
That
where
was a
the
great
lot of
webinar.
Formula called
to
the
take
R-square.
place,
And
and
a
Also
lot
some
of
of the
called the
major
really
hardware
great
R-square.
information was shared,
that
and
is
we can,
quantum
I
And the
think you
computing
can
formula
tell
for
that
R
from
square
all
is
the
1
great
minus sum of the
questions
square
everyone
residual
attending
Yes,
set
and
it is
divided
not
by sum
reached
of
a
square
maturity
total.
stage.
But
As,
quickly, before
we
we
have
wrap
Sum of
up,
square
I just
residual
want to
is
note
sum
a few
of
other
yi
upcoming
minus y carried to the whole
webinars.
square. What is this
We'll
called?
be doing
What is
4
sum of the square
over the
residual
next
people
called?
realize
2
that
weeks
it's a
or
problem,
Some other
so.
term which I
and
The
they're
next
trying to
webinar
address that.
from this
What is sum of the square
from
residual
this
called?
specific series standard, the
very
standards
good.
activities
I
for
believe we
webinar
yi
series
minus y squared
will
the
be
whole
on
square.
deep learning
I
on
What is it
do
April
called?
want
5th,
to
also at
take this
9 a.m.
moment to thank
Eastern.
Dr. Murugeson for your
The additional
presentation.
webinars coming
I'd
up,
also like to thank
there's
all of
one
you for
tomorrow on
attending.
Thursday.
We have several webinars that are
Mean
coming
square
from the
up
Build
error
Your
in
Career
or
webinar
Our
cross
next
series.
function,
distinguished lecture webinar
There's
series
one
webinar will be
next
on
week on the
cybersecurity.
31st from
And if
our
you remember, I said very clearly
distinguished
that if my model has to be
lecture
efficient, my
series, which is
yi
part of
minus
the
y
Distinguished
carrot or
Visitors
y
Program.
minus y minus carrot
And
has
then
to be
we'll
equal
have
to 0.
2
I
That
don't
on
is
know
the
if
yi
week
and
you've
y
of
had
carrot
these
has to
April
be
people
equal to
4th.
before.
each
I don't know
other.
if you've seen
Um,
them,
the
but
So
one
my
from
sum
they
of
have a
as
wonderful
my
mentioned, the
function
one
has to
on
be
deep
minimum.
learning, and we'll have another
My
one
sum of the
from
square
the
total
Build
is
Your
sum
Career
of y minus
webinar
yi
series.
minus y
You'll
average
be
is
able to
equal to
register all of those
y average is not
in the email you
5
If I
receive
use this
in
formula,
the so
sum of the
with
square,
the
if my
slides
sum
and
of the square
recording.
residual has to be minimum,
Again, I would like to thank
this divided by
everyone for
this has to be
attending.
minimum, which means
educationally. We have
if
several
my
Dr.
R
Richard
square
G.
is equal
for
to
his
1,
great presentation, Edward for moderating, and I hope you everyone has a great rest of your day.
Some of those.
so if
Thank
my
you, Scott,
model
and thank you all.
is equal to,
Thank
if I
you.
can get a score of around 1.
that we'll be sending out to you in the email.
Or if we get
Registration for these is now open, and we will be
0.85,
sending you a
0.95
link
is
to
very
the
good. You'll
event
never get
along
one
with the
any
recording of
time.
this webinar.
But this is the
Again,
formula
thank you all
to
for coming,
calculate
and
the accuracy
Dr.
of a
Murugeson,
regression
thank
model.
you. This
And
was
I
a
will
great presentation
open
you've
another
given to
script.
us today.
Thank you.
There was another
Thank
script
you,
here
and
where
all
I
the
have
participants.
calculated the model
It's my
efficiency.
pleasure. Thank you.
You will get this complete
Great.
set
Have a
with
great
you. Okay,
day
don't
and a
worry.
great
All
night,
this will
depending
go
on
with
where
will
everybody
be
is.
provided to
Bye.
you. So now this is the one.
Thank you.
Okay, I will execute this. I have just added some additional lines of code to calculate the R square. So since I'm going to start from beginning, I'll have to do everything from the beginning. So I import the library, import the data set. Import all the 3 libraries. Then I'm also importing another library called R2_score, from where I'm going to use the formula to calculate the R square. Okay. Then I did this already earlier. I split into X and Y. I did the split X test, X train, white. Okay, then forget this. Feature scaling, I skipped it because it was part of the algorithm. Train the model, predict the model. And here I'm using, let me just make it bigger. See the function here. I'm saying R2 score is the function. I'm giving y test and y pred are my parameters. And if I execute this with 2 decimal places, it gives me an R score, R2 score, R square of 99.97%, which is excellent. So I can say that this particular regression model is what I can give it to the client. So what happens is when I give this model to the client and the client is entering some new years of experience, the model will predict the salary. The third way of graphically showing it is using Matplotlib. And in Matplotlib, what I do is this is what I'd shown you in the earlier. This is my years of experience, salary, sorry. This is my years of experience. This is my predicted line, y caret, and these are my y test. So this gives you an estimation of how my model is working with this set of data. So even visually you can see that barring these 2 points, all these are very close to the predicted line. And obviously the best thing or the metric that we use, the R square, that will be used for calculating the accuracy of your regression model. Is this clear to all? The end-to-end process that I've done, is this clear to all?
Yes, sir.
Okay. Let me see, anybody has, so everything is clear. Oh, that was 236. Okay. So I think it's Shanti who's responding most of the time. What about others? Have you guys understood? Okay, fine. If you don't answer, I'll assume that you have understood. Okay, so that's we'll go with that assumption. Okay, so now you have done simple linear regression. Now let's get into multilinear regression. So let me close this. And what I will do is to initialize the values in the console and the variable explorer, I can what is called restart kernel. So when I restart, all the values will get initialized, blanked out. Okay. While this happens, I will go back to regression, multiple linear regression, and select. Okay. And in this, I've got a files called multiple integration.py and my data set is this one. Now, what is my data set? So I have got 50 startup companies. You know what is a startup company, right? Then today a lot of startup companies come, they become unicorns and all those stuff, all those words you have heard. Now I am an investor. Okay. And I want to invest in this startup company. Okay. So I have collected the information about all the companies, those 50 companies. So what I've captured the amount of money is spending on research and development, the amount of money spent on administration, amount of money spent on marketing. Marketing could be promotional expenses or it could be advertising and so on. In which state the R&D, which state that company is spending, and the profit the company is making. Okay. So a company wants us to come out with a model which will help us to predict the profit. Okay, which will be able to predict the profit. Okay, and based on that, it can take a call whether you should invest in that company or not. Now, out of these, can somebody tell me which is the dependent variable and which are the independent variables?
Profit is the dependent variable and remaining are independent.
Yes, Shanti, please go ahead. What you said?
Profit is dependent variable and remaining are independent variables, sir.
Good. Right. So profit is your dependent variable, and so this is a multivariate regression, right? Okay. Very good. Now let us go through the data pre-processing steps. Importing the libraries, you have to do. Importing the data set, yes, you also identify the independent variable. What about data categorization? Is it required? Do we need to do the data categorization?
Yes, sir.
Why?
State is represented in the textual format, sir.
Correct. So you have a state field which is a text format, right? So that will not work. We'll have to convert that into a array of dummy variables, right? So you have to do data categorization. What about feature scaling? Anyway, splitting you have to anyway do. That is goes without saying. What about feature scaling? Is it required? Is feature scaling required?
Yes, sir.
Why? You are right, but why?
Because the attributes are in different scales, sir.
It could be in different scales. Yeah, I mean we because your administration could be in thousands, your marketing could be in 10,000s, your R&D spend could be in millions. So it could be in very value. So always it is recommended when you have such values, you should always do feature scaling. Okay, good. Now that we know this one, so let us. So the concept is everything same. I will do the data processing, modeling, evaluation, and find out the accuracy. So I will take the first one, second one, third one, take the R2 score. Then if I see the startup, there are 50 rows and 5 columns. So you see R&D spend, you can always expand it, right? State and profit, right? No, there is no missing value, so we are good. So that's okay. So I identify the independent variables. So in this case, my independent variables are the 3 expenses and the state, right? Then your Y is your profit. Y is your profit, right? And then now see your X here. Now your state field is this one. Now you have to convert it into a one hot encoder, label encoder, one hot encoder. You have to convert it into a dummy variable. Now if I execute this, now if I see the value of X, now if you see that the array of dummy variables has moved to the left, to the extreme left. While my state field in the original data was to the extreme right, or not extreme right, but to the right, when I did the data categorization, my dummy variables got moved to the left. So you will have the 3 dummy variables because there are 3 states, unique states, and I got the 3 expenses. Okay. Now, so what I will do, I have done the data categorization. Now I will split the data. I have got 20%, that is 0.2 test set. That means 20% test set, 80% training. So out of 50 records, 10 records are test and 40 records are training. Here again, I don't do feature scaling because it is inbuilt. So I just commented here because I'm using the same linear regression algorithm. Whether it is single univariate regression or multivariate regression, I'm using the same class, linear regression class. Okay. So again, I will do this. Sorry. And again, I will calculate. So I did a widespread and did a calculation. My R square came to 93%. My R square came to 93%. Now, since you guys are in the final year, I will cover something little more because one of the very important things you should know. See, as a customer, I need to know which of these variables have the highest impact on profit. See, all the variables need not contribute equally to the profit. I need to know as a customer which variables are having the highest impact or dependence on profit. Okay. I will introduce you to a concept. Okay. And this is again statistics. So you have to do some work studies here. Okay. But I want to explain you this concept, and I want you, when I explain, after I explain to you, when I give this code to you, I want to execute this code, and after executing the full script is given. I'm not going to execute the full script for you, but as a homework for you. But I'm going to explain the concept. So at the end of it, you have to, what I'm trying to come out with is that there'll be one variable out of one feature out of these, which has got the highest impact on the profit. Okay. Now, what is this concept? There is something called hypothesis testing in statistics. So typically, when I do hypothesis testing, I test a null hypothesis. And there is something called alternate hypothesis. Okay. So my null hypothesis says here that none of the features and a feature has no impact on profit. We also use the word statistically significant, less statistical significant. My alternate hypothesis says that feature is what? Your independent variable. A feature has statistical significance on my dependent variable. Statistical significant on my dependent variable, which is my profit. A feature has statistical significance on profit. That is my alternate hypothesis. I have a null hypothesis which I'm testing, which says that the feature has no statistical impact or no statistical significance on the profit. And alternate hypothesis is feature has statistical significance on the profit. Now, in statistics, there are various concepts like the if you heard of normal distribution, if you heard of there's a lot of z-score. There are various terms. There is something called t-student distribution. Okay. That is called variance, population variance. There are various terms. Okay. And there is something called p-value for any feature. Now, this p-value is derived in statistics using multiple ways. One is using the z-score, one is using the chi-square table. There are various tables available by which you can find out. It is called the chi-square table or z-score. There are various ways by which you can calculate the p-value for any feature. So if there are, so we are now concerned with three important features: R&D, admin, and third is what? Marketing. And you want to know which of these features is having the highest impact of profit. You have to find out maybe the one or the two features, most prominent features. So what I do is, for each of these variables, I calculate the p-value. And my hypothesis says there is something called a significant level. It is typically either 0.01, 0.05 or 0.1. And typically we use 0.05. Okay. And significant level is basically what the equation says is that if my p-value is less than significant level, then that feature is statistically significant on the profit, which is your dependent variable. If my p-value is greater than significant level, so that means when it's statistically significant, that means my alternate hypothesis is applicable. If my p-value is greater than the significant level, which is 0.05, then that feature has no significance on profit. Are you guys clear till here at this point of time? What I've done? Is this clear to all? Well, you may not able to grasp everything because you will not be having the background of all this p-value, chi-square, z-score, normal distribution. So that's why I said, you need to have a very strong statistical knowledge. But for now, just remember, you can do some research on all this. But for now, remember that if the p-value of the feature is less than the significant level, which is 0.05, then that feature is statistically significant on profit. If the p-value is greater than significant level, then the feature has no significance on profit. So what I do is I use a concept of backward elimination. So typically, in this case, you are only having 3 features, but you will have 50 features, 70 features, 90 features in typical industry. And then you have to really squeeze and find out which is the one which is having the highest significance on the profit. Okay. So what I do, I take the p-values of all the 3. Suppose the p-value is 1, 0.8 and 0.6. What I do, I take the highest p-value, which is more than 0.05. So which is the highest? 1. Okay. Since 1 is greater than, see, ideally, what if I have gone through this equation, if you have seen all these 3 are greater than 0.05, right? But if that be the case, then obviously your feature, all the features would have no significance on the profit. But that's not how it works. You take the highest p-value 1, and which is more than 0.05, you eliminate that feature. So If the p-value has no significant profit, so you eliminate that feature. So if this is P1, this is sorry. So this is F1 feature 1, feature 2, and feature 3. So if my feature 1 has the highest p-value, I will eliminate F1. Then I take F2 and F3, recalculate the p-values for both, and again find out the p-value which is the lowest, which is the highest. And that p-value which is more than 0.05, any p-value, so take the highest one, more than 0.05, eliminate that. Then take the remaining features, recalculate the p-value. You will see as you go ahead, your p-value will go on reducing. Okay, and then you will find one or two variables or features which is having a p-value less than 0.05, and those are the variables which are statistically significant or having the highest impact on profit. And this process of eliminating one variable after time is called backward elimination. So you are, imagine there are 50 features, you eliminate one by one till the time you get one or two features which is having the highest impact on the profit. And this is called hypothesis testing in statistics. Is this concept clear to all? Shanti, have you understood? Yes, Shanti, what happened? Navya? Have you got an idea? I mean, I don't expect you to be just got this idea of p-value, significant factor, significant level. Are you clear on this?
Clear, sir.
So what I want you guys to do, when you go to the script, you run this. So what I'm doing is I'm taking all the variables and I'm using this regressor OLS summary function. Okay. So let me just show it to you once so that you get an idea. I will execute for once. So I did this. Here what I'm doing, before x1, x2, x3, I'm appending something called x0. So I'll have x0 plus m1 x0. So x0 will be value of 1. Okay. So we are just creating one x0 feature variable. Okay. Now, so I'm taking all my variables. So there are 5 variables, x0, x1. So x1, x2, x3 are your x1, x2. Okay, so what I've done is I have eliminated one dummy variable. So if there are 3 dummy variables, I have something called a year. I have eliminated one dummy because if I know, if I have 3 countries, right? So if I know the value of 2 countries, I know which is the 3rd country. So I can always eliminate one dummy variable out of the 3. That's called a dummy trap. So you can, idea is to reduce the number of variables. So you eliminate one dummy variable. That's basically you are eliminating one dummy variable here, or you are avoiding the dummy variable trap. Okay. Now having done that, so what I'm having 2 dummy variables. I'm having 2 dummy variables, then x2, x3, x4, x5. Okay. So how many variables are there? X 0, 1, 2, 3, 4, 5. So there are 6 variables here. So in X you have got x0, x1, x2, x3, x4, x5. Your x3, x4, x5 is your R&D expenses, the marketing expenses and the promotion expense. Now what I do is when I run this, you will see here for each of the variables, this is the constant, this is the x0, x1, x2, x3, okay, x4, x5. So this x0, this x1, x2 are the two dummy variables. x3, x4, x5 are the three expenses. Now you will have a p-value here. Do you see a p-value here? And you take the p-value which is the highest more than, okay, the highest p-value is 0.953. Sorry, 0.99. Since this is 0.99, I eliminate x2 and I rerun this with 0, x01, x1, x3, x4, x5. I eliminated x2. I eliminated x2 because it had the highest p-value, right? So I take x0, 0, 1, 3, 4, 5, right? So I continue this again here. I find out the p-value, eliminate that feature. Go till the end, till I will get one variable, which is x3, okay? This x3 is your R&D expenses. So this R&D expense is having the highest impact on profit. So I want you guys to execute this as part of your exercise and find out, and you will come to the conclusion that R&D spend has the highest significance on the profitability of the company. So this process is called hypothesis testing. And I have explained everything on this slide. So let me go through this slide. This is all the code. This is how the backward elimination works. So select a significant level, 0.05, fit the full model with all possible predictors, consider the predictor the highest p-value. If p-value is greater than significant level, remove the predictor. So I remove that variable. Then again recalculate the p-value, calculate the full thing till the time I get the variable with the lowest p-value. And that is how I find out those variables which has got the highest impact on profit. That's called hypothesis testing. Is this clear to all of you? Are you guys clear on this? Shanti, are you clear? Navya? Rohit? So I want you guys to do some study on p-value, z-score, statistical value. This is very important. If you don't know these concepts, then now you know the theoretical part. So try to read it and then you try to understand what is this hypothesis testing. Okay. So please do this as an assignment and find out and conclude that the R&D expense has the highest significance on the profit. So any questions on the regression before I go to classification? Are you clear on a single regression? We talked about multivariate regression. We talked about hypothesis testing to find out those variables having the highest impact on the dependent variable. Very, very interesting. Okay, fine. So what I'm going to do, I'll go to classification. All this I will share with you, don't worry. Polynomial regression is something you can try it out. I'll give you the code. Okay, you can try it out. So let me go to classification. So what is classification? As I said, it's a labeled data with discrete set of values. And this is one of the most popular data sets called the vertebrate data set. Okay, which you can get it on the Kaggle site. If you see go to the Kaggle site, kaggle.com, you will get a lot of data sets, right? There's a lot of competition happening. So one of the standard data sets which everybody learns is the vertebrate data set. And this is the example of multiple features like the name, the body temperature, the skin cover, the gives birth, aquatic creature, aerial, and so on. And all these features contribute to a class label, whether it's a mammal, reptile, fish, amphibian, and so on. Okay. So these are the class labels with discrete set of values, and this is an example of a classification data. And the process for the workflow, irrespective of it's a regression or it's a classification, it is the same, right? So in classification type, you have 3 types. One is called the logistic regression. There are decision tree classification, random forest. Okay. Now there are other classification types also, like the K nearest neighbor, KNN. There is something called naive Bayes classifier. There is something called support vector matrix. There is something called kernel support vector matrix. So there are various algorithms in classification which we use. Okay. So I will cover the logistic regression first. So what I do is, I will just clear the kernel, restart the kernel. While I do that, I will shift my folder to classification, logistic regression. Logistic regression. Let me close this. This is all done. And I will go to files. I will go logistic regression.py. And social network ads.csv. Now let me expand this. So this is something we also covered in the workflow, that there's an automotive company. The automotive company is asking the customers to log in into their portal. So they log in with some user ID. We capture the gender, we capture the age, their salary, estimated salary, and they click on a button or something which signifies whether the person is going to buy a car, is likely to buy that particular brand of car or not going to buy. So I want to come out with a model which will predict whether the person is going to buy the car or not going to buy the car based on his profile. Now looking at this, which is the dependent variable and which are the independent variables? Which is the dependent variable and which are the independent variables? Anybody? Yes, Sheikh. What is your answer? Yes, Shanti.
Purchaser is the dependent variable and remaining are independent variables, sir.
Okay. Why is user ID an user ID is an independent variable? Why is user ID an independent
Every person have their unique user ID,
so
and it does not depend on other attributes, sir.
Yeah, so user ID has no significance, no? I don't care whether it's Arunjit or Shanti or X or Y who is going to buy the car. Okay. So for me, user ID has no meaning. It's like a name of the person. If I have a name of a person like Arunjit or so on, it has no significance on my statistics. I want to know which are the combination of age or maybe salary, the profile, who are going to buy my car. How does it matter if it's Arunjit or this? So user ID has no meaning. It's a unique variable for a person who is logging to the portal. The user ID doesn't have any significance. So that is eliminated. Got it, Shanti? Why we don't need user ID? Everybody, have you understood why you don't require user ID?
Yes, sir.
Okay, then you have gender, age, and salary. Yes, they are independent variables. Now, one of the things which customers told me that you don't worry about the gender, don't care about the gender, just focus on the other parameters. So in this case, gender will not be required because the client has told me that you don't need to require it for analysis. So I will take age and salary as my independent variable and purchase as a dependent variable. Okay, very good. Coming to the data pre-processing stages. So importing data, data set, we know the independent, dependent variable. What about data categorization is required? Do we require data categorization?
Yes, sir.
Why?
Gender is in textual format.
Okay. What about anybody else? So the way I will answer this is, if my gender would have been considered as part of my analysis, then I would have done data categorization, but I'm ignoring age, no? Sorry, I'm ignoring gender because client is not concerned about it. When there is something which is present, which I'm not using for analysis, then why do I have to do data categorization? I'm taking only age and estimated salary as my independent variables. So where is the need of data categorization, right? So in this case, because if gender would have been part of my analysis, then absolutely I would have used label encoder to convert this into 0 and 1. But since the client has told me that I don't have to use gender, then why do I have to really care of data categorization? Is this clear to all of you, my answer? Is it clear, Shanti?
Yes, sir.
Okay. So we don't have to do data categorization. Very good. What about splitting the data? You have to do. What about feature scaling?
We need to do feature scaling, sir.
We need to do feature scaling because I got age and estimated salary, which are in different scales, right? Very good. So now let's go back to our script. So let me also make this big. So concept is same, import libraries. Data set. So you have got 400 rows and 5 columns. Okay, these are the 5 columns, and I'm not looking at okay, so there is no value, there is no missing value, so we are good. I'm talking age and salary as my independent variable. So my X is age and salary, and my Y is sorry, Y I have not defined yet, so I have to first say Y. Now I say Y. So my Y is whether is purchase a car or not purchase a car. Very good. And then I'm taking 25% test set and 75% training set. So 300 records will be training and 100 records will be test. So when I execute this, okay, so I have 300 of training and 100 of test. Okay. In the case of logistic regression, like if you remember linear regression, I had explicitly did do feature scaling, which was inbuilt in my program or in my linear regression algorithm. But in the case of logistic regression, it is not inbuilt in the logistic regression algorithm. So I had to explicitly do the feature scaling in my program. And that is where I have used here standard scaler on xtrain and xtest. So if I see xtrain, and and if I see X test, if I do this standard scaler, as I said, you can use either standard scaler or min max scaler, anything of the two. And now if I see the value of X train and X test, you see the values is 0.2, 0.0, 0.38, 1.39, 0.42, and so on, right? So that is how I've trimmed down the value to a common base scale. That's where I use feature scale. Okay. Now then, again, I've completed my data pre-processing steps. Then I train the model using logistic regression, taking X train and Y train, same concept. Then Y pred and Y test. Y pred, I predict based on X test. What could be the possible values of Y pred? What could be the possible values of Y pred?
Zeros and ones, sir.
Correct. So Y pred also will be 0 and 1. Okay. And again, I will compare Y pred with Y test. So I can go to my, I can double click Y pred. I can double click Y pred, double click Y test, and do a sort of visual comparison, which I did for regression earlier. In the case of classification, we use another matrix to calculate the efficiency, and that's called confusion matrix. In the regression, we use the R square. In classification, we use confusion matrix, and I will explain to you what is confusion matrix all about. Okay. Please pay attention to this. Now you have an example of a test data. So you have done the training of the model with the training set. Now you have a test set of, say, 100 records, 35 plus 5 plus 50 plus 10. And I plotted a chart of a predicted value and the actual value. So predicted value, as I said, is Y pred, which could be 0 and 1, and Y actuals for the Y test is again 0 and 1. Now imagine there are 35 samples which are saying predicted is 0. That means he's not going to buy the car, and actual is also 0. He's not going to buy the car. So very, very fine. So model is behaving perfectly for this set of data. Come to this 50. So there are 50 cases where my predicted value says my model is predicting that it's going to buy the car, and actually will buy the car. Very good. The model is behaving perfectly fine. Look at these two examples. Now omit these red exclamation and the white exclamation. I'll talk to you later. There are 5 cases where I predicted that he's going to buy the car, but actually is not bought the car. This is an error, right? Because the model is not predicting the actuals. And there are 10 cases where you have predicted that he's not going to buy the car, but actually is bought the car. So this is another example of an error. So if you calculate the accuracy of the model, it will be 35 plus 50 divided by 100, 85%. And if you calculate the error, it is obviously 1 minus accuracy. So it is 15 divided by 100. So that's 15%. Okay. So now we have two metrics. One is the accuracy rate. One is the error rate. Let us go further. Now let us represent it in a different way. So I have got the true class, that is actual value, and this is a predicted value. This is typically we represent like this. So plus is means, suppose here I am talking of a healthcare industry where I have got two values, plus or minus. Plus means a person is having cancer, and minus means a person is not having cancer. So there are two dependent variable values. Either he has cancer or does not have cancer based on number of features. Now here I am saying I predicted that he has got cancer, and actually he has got cancer. So we are very good. This is called true positive. Here again we have predicted he does not have cancer. Actually, he does not have cancer. Minus means does not have cancer. So this is called true negative. So this is perfectly fine. Look at this. Now this is yellow color. Huh? What is this? I have predicted that he has got cancer, but actually he does not have cancer. This is an error, but this is not that severe error, because what I'm saying, I predicted he has got cancer, but actually he does not have cancer. Okay, this is an error, but it's a less fatal error. Okay, it's called false positive or a type 1 error. But look at this. But though this is also has to be alarming, but this is more alarming. What does this say? This says the model predicts he does not have cancer, but actually he has got cancer. When the model predicts he does not have cancer, but actually he has got cancer, this is a very, very severe situation. And these are the what is called the false negative or type 2 errors, and you have to eliminate the type 2 errors for the model to be deployed to the client. The higher the type 2 error, the model is not at all correct or not at all good for the client customer. Okay, so it's very beautifully mentioned here what I talked to you: true positive, true negatives, false positive, false negative. So if you talk about the KPIs, which in industry we call it as a key performance indicators. KPI means key performance indicators. There are 4 metrics that we use. Metrics means METRICS, metrics. One is classification accuracy, which is the accuracy TP plus TN, PP plus TN divided by total. This is for the test set. We always consider with test set. Always remember. Misclassification of the error rate is obviously 1 minus classification accuracy. That is FP plus FN divided by total. There is something called precision, which is TP divided by total number of true predictions. And total number of true predictions is TP plus FP. And there's something called recall, which is TP divided by TP plus FN. Okay, so false negative is the most severe. You have to eliminate this. If you want to make this 0, then only my recall will be close to 1. Similarly, FP, which is false positive, also has to be eliminated. But the first you have to eliminate is FN. And this is TP divided P plus FP. So if my FP is also less, my precision has to be will be high. So in the case of confusion in the regression classification model, we use 3 metrics to calculate. One is the accuracy, second is the precision, and third is the recall. And all these 3 values need to be very high in order to recommend the model to the client. If you more than 0.85 or 85%. Okay, and this is an example how you calculate the classification accuracy, precision, recall. Now you will see your accuracy is high, but precision recall is also very high. Is very low. So I will not recommend this. Though my accuracy is high, my precision and recall is very low. So I will not recommend this model to my client. Okay. So this is how we calculate the confusion matrix. Any questions on this? Have you understood this? Let me just grab some water. Is this clear to all of you? Have you guys understood this? Okay. This is very, very important. Yeah. How do you measure the accuracy, the various metrics? One is the accuracy, one is the precision, and one is the recall. Now let us go back and show it in the sheet here. Now I'm going to use this. It's the same thing. In the case of there, we use the R2 score. Here you're using R2 score. It's an R2 score confusion matrix, but the parameters are the same, Y test and Y parade. Okay. So when I do this, and I calculate the CM, The confusion matrix is 65 plus, the accuracy is 65 plus 24 divided by 100. Similarly, you can also calculate this Pearsall recall. There is a method, there's something called classification report in Python by which you get all the three matrices. But for now, I'm just taking accuracy. So accuracy in this case is 65 plus 24 divided by total 100, which is 89%. Okay. Now, if I want to show this in a plot, the test set. So what happens here, you have what is called a prediction boundary. This line is called a prediction boundary. And this prediction boundary divides the predicted value of 0, that means not going to buy the car, and predicted value of 1, which is green here, which is going to buy the car. So you will see some red dots, which are the actual data, and the green dots, which are the actual data, test data. We are only talking of test data here. Huh? So you will see some green in red, and you will see some red in green. So these are the type 1 or type 2 errors. So this way you can represent to see whether this model is good enough. So you will see there are some greens here, and there are some reds in green. And if you probably add, that will make up that 11%. 3 plus 8, we show that 89% is accuracy. So the error, which is your type 1 plus type 2 errors, is around 11 of them, which is 11%. So this is how, using Matplotlib, you have a classification, what is called boundary, and then you have prediction boundary, and you have a division where you see the 0, which is a predicted value of 0, and predicted value of 1, and the actual values, and you can find out the type 1 and the type 2 errors. Okay, so this is an example of a classification model using logistic regression. Now, typically what happens, right, in industry, when you have, the way we do a classification model is, if there is one data set, here you are using social networks, you use the data set and you execute all the different types of models, like the decision trees, your random forest, all this with the same set of data, and try to find out that model which is giving you the highest accuracy, precision, and recall. And that is the model you need to inform the guy. So for the same set of data, you can try out different models, because different models or algorithms are written to represent to basically try to find out the pattern out of data in a different way. Okay, so you have to go through all the models and see which model gives you the highest accuracy, recall, and precision, and that model you will try to recommend to the class. So what I'm going to do now, I'm going to use another decision tree model. Now, decision tree, if you know, works on the concept, you all know, if there's a decision tree, you have a root, you have the various nodes, and you have a leaf, and the leaf represents whether it's a dependent variables, whether somebody is going to buy the car or not going to buy the car, or somebody has a disease or not going to have a disease. So decision tree uses a algorithm called the ID3 algorithm. So what it does is that, imagine you have this x1 and x2, like your age and salary, and green means is going to buy the car, red is not going to buy the car. So the decision tree classifier uses a statistical method called the information gain, or what is called the entropy. So using the information gain and the entropy, what it does, it will try to split, when your decision tree, whether you're going to split based on x2 or you're going to split based on x1, and that split is represented here, very nicely represented here. Like, suppose if this is how your data is scattered, you do a split one here, so you have green and red on the top, and you have split here. Then you have a split 2, so you have divided this 2. Split 3, you have this, you have divided this and this, and split 4, again you have divided green and red. So this is how you split till you get all the pluses together, all the reds together, and all the greens together. Okay, so this is again a statistical method called information gain. So using information gain, you for x1 and x2, you find the information gain for both x1 and x2, and the one which gives you the highest information gain, that then the split will happen based on that. So there is again a separate statistical measure called information gain, where you can find out for which attribute is giving the highest information gain. Right. So this is how you will do a decision tree. Now what I'm going to do, I will execute the decision tree model or the decision tree algorithm on the same set of the same data, which is the one which I use for logistic regression. So let me do that. So I'm going to restart my kernel. I'm going to let these social networks be there because that's what I'm going to use. Okay, let me change my folder to decision tree. And there is a file called decision tree classification.py. Okay, I'm using the same data set here. Okay, see, and let me see what is the efficiency I get. NumPy, Matplotlib, pandas. This everything is the same. No change. No change. But again, I have to do the again here, like logistic regression, I have to do explicitly do feature scaling, which is not inbuilt in the decision tree algorithm. Then I use the decision tree classifier and I do the extrain. Sorry, I have not done this yet. Sorry, this I did right. I have to do this first. Let me try from again. Sorry, let me do it from scratch. Do this. Split. Feature scaling. Decision tree. Bipred. And now using the decision tree, I calculate the confusion matrix. Now if you see here, for the same set of data, my accuracy is 91%, 62 plus 29 divided by 100. In the case of logistic regression, I got an accuracy of 89%. So between the two, if you give me an option, I will use decision trees as the preferred model. Okay, but decision tree has got some issues, and one of the issues it is facing is a problem is overfitting. So when I say overfitting means a decision tree tends to give very high test errors. While the training errors are less, the test errors are very, very high. You have something called an underfitting, where both the testing and test errors are high. You have got just fit, where your test errors and training errors are less. And you have got overfitting, where you tend to have high amount of test errors. So to eliminate that limitation of overfitting, the data scientists came out with a revised algorithm called random forest. Random forest is also called an ensemble method or an aggregator method. Okay, and the way it works, it actually is an extension of decision trees, but it gives you a higher efficiency. And I will explain you how it works. In the case of random forest, one thing we have to do is that since it works on the concept of decision trees, you have to give one of the input as a parameter to the random forest how many decision trees you want to take. It has been found that as you increase the number of decision trees till a particular point, not always, there will be a threshold, the accuracy tends to increase. Okay. So what you need to do is you need to, when you work on this random forest model, you have to play around with this parameter, number of decision trees, and see which is the one which is giving the highest efficiency, highest accuracy. So how it works is like this. Let's go back to the example of age, salary, and purchase, yes or no, right? And where the age and salary is your independent variable, and 0 and 1 is your dependent variable. And assuming you assume that you have got 1,000 records, right? Let's say you got 800 records of training set. And 200 records of test set. So what I do here, I decide the number of decision trees I'm going to take. I say I'm going to go for 10 decision trees. So I'll have D1, D2, let's say 5 for now. D4, D5. Take say 5 decision trees. I split the 800 records randomly so that total is 800. So I'll say 100, 150, 200, 150, 120, 200. And this is 230. I think total is 430, 550, 650. This is total 800, right? So what I do, I run this 100 on decision tree 1 using the decision tree algorithm, 150 on decision tree 2, 120 decision tree 3, 4, and 5. So I run this 5 independently. Okay. Then I take the test set. I take the age and salary. I take the age and the salary. And what I do is, I feed this to D1 and get a predicted value of 0 and 1. Say I get 0. I run it on decision tree 2, the same test set, first record. I run it on decision tree 2. Because I've run this model, right? I've run this 5 different models. Now I'm predicting with a new set of data. So my new set of data is my test set. So I entered age and salary, which is an independent variable. Enter to D1, I get 0. I get 1. D3, I get 1. D4, I get 0. And D5, I get 1. So what it says, if this is the process, then which one to select? So for the first set of test data, I ran for all the 5 decision trees, and then I take the one which is the highest vote. So the highest occurrence is 1. And there is 5 occurrences, 3 occurrences of 1 and 2 occurrences of 0. So in that case, I will take the final value of 1 because 1 is having the highest occurrences. I will do that for the second test data. I will do that for the test data right up to 200 records. And this is how I run the random forest. Is this clear to all of you? Have you guys understood the concept of random forest? Yes or no? Shanti, have you understood?
Yes, sir.
Rohit, Navya, have you guys understood? Zamila, Shravani? Can I get, those are not speaking, can I get quick yes or no on the chat box, please? Okay. Now let us go and execute the model. See, very interesting. I go back. I clear my, restart my kernel. Meanwhile, what I'm going to do, the data set I will open PCS, I will open classification, random forest, select folder. And here I've got the same data set. Now I'm going to use random forest classification of PY. Okay, so what I do, same thing, no change. Data processing I'm doing. All this I'm now doing 3 together, faster. Date, feature scaling. Now, what I'm doing here, I'm using a random forest classifier method. Number of estimators is number of decision tree, and this is what I'm going to play around with. I'm using entropy, which I talked about decision tree, and I'm going to train the model with 10 decision trees. I predicted, I come out with a confusion matrix and see the value of confusion matrix. My confusion matrix is 91%. In the case of decision tree 3 also I got 91%, right? If you remember, I got 89 for logistic regression. I got 91 for this. Is the same thing. Let me increase the number of decision trees. Make this 20. Okay. So I don't have to do the data processing. It's already done. So let me start from here. Predict. And now I come with CM. Now do you see that my accuracy is 92%? As I increase the number of decision trees, my accuracy has now gone up from 91 to 92%. Okay, very good. Let us make this 30. So I'm taking 30 decision trees, yeah? So again, start the fitting, prediction. It is not increased. Still, it is giving me 92%, right? It is still giving me 92%. Okay. Let me try with 40. Now with 40, I have got an accuracy of 94%. See, it has increased with as I increase the number of decision trees. See, though if you increase the number of decisions, it's going to be computing intensive, but nowadays it doesn't matter because everything is on cloud. But if you see now, with the increase of number of decision trees, your accuracy has gone up 94%. 64 plus 30 divided by 100. Okay, let me try 50. Does it make a difference? So now I calculate my CM. CM is now 92%. So there is an optimum number of decision trees after which it never increases, it goes down. So that optimum, if you see somewhere between 40 and 50. So you have to play around with number of decision trees till the time you get the most optimum accuracy, recall, and precision. Is this concept of random forest clear to all? What I did, I played around with the number of estimators, which is my number of decision trees. Have you guys got this concept clear?
Yes, sir.
What about others? Okay. So we covered random forest, we covered decision trees, we covered logic trees. Similarly, you will run this with all KNN other methods also and try to find out the one with the highest accuracy. So I have covered the theory part, whatever I wanted to cover today. Is there any questions before I go to the assessment again and wind up for the day? Any questions? Ma'am, can you get HOD sir also if possible at the end of the session? In another 10 minutes? Is she there or not there? Shanti, where is madam?
Ma'am is not there in the meeting, sir.
Can any of you call her? One minute. Can one of you call her, please? Your HOD is Patanjali Shastri, sir, right?
Yes, sir.
Can you call ma'am? I wanted the HOD to join if possible. Let me just call him. Just try to reach out, ma'am. I will try to reach out to HOD, sir, please.
Hello.
Yeah, ma'am, you're
Hello.
there. No? Okay, okay. I wanted to be there for the end of the session because I tried to reach out to HOD, sir, but I think he's busy. So
Yes, sir. Sir,
I
is
want
it
to.
some other?
Yeah. I spoke to him. I think he's into some meeting. That's okay. That's okay. But I
Yes,
just
sir.
wanted
Sir
to
is
be
in some.
there. No, that's fine. That's fine. So I just want to remain in this call because I want to get some feedback from the students after this session, and then I hope you're doing an official you have an official feedback form after this session.
Yes, sir. We will be taking the official feedback, sir, because we had to file also.
Okay, very good. So I just wanted to, after the session, to take some verbal feedback also from the students. That's why I also wanted you to be there. So I will
Sure,
take
sir.
another 5 minutes. You can just be on the call. Okay, please be there. Yeah.
Sure, sir.
Thank
Sure,
you very
sir.
much. Thank you. Okay, guys. So let me go back to the assessment. If there are no questions, where is that? Sorry, I closed it by mistake. Okay. Let me open up the. Okay. I needed to open up the chat box. Okay, great. So, okay. So we covered the first 9 questions. Good. Question number 10. Which are the various algorithms used in supervised learning?
Logistic regression.
Okay. Only logistic regression, Shanti? What about others? What is the options you all feel? B and C. Rohit is saying B and C. Okay. I'm talking about supervised learning. Please keep in mind. And when you're talking of supervised learning, we are talking of regression and classification. So Shanti, linear regression is part of regression, right? How we are skipping that? Logistic regression is part of classification. So that is also there. Associated learning is part of unsupervised learning. Learning association, right? NLP is also a classification. Obviously, I would not have expected you to give this answer, but I will explain you with an example. NLP, you know, stands for natural language processing. Okay. There are a lot of natural language processing libraries which are used in machine learning today. And I will give an example. I go to a 5-star restaurant. I eat some, okay, I order some food, I eat the food. And at the end of it, the manager or somebody comes and either gives me asks me to fill up something on a notepad, or he will ask me to fill up a physical form. And that physical form, you would have to write about the food, the feedback about your food. So it may be a good feedback. You may say sour, you may say sweet, you may say whatever, right? Now that data which you are entering, that data is fed into a machine learning algorithm. And that machine has been trained in such a way that it is able to analyze whether it's a good feedback or a bad feedback. And that's where you use a lot of natural language processing libraries to try to segregate all the wanted and unwanted words. And then as you train the machine will be able to predict whether it is a good feedback or a bad feedback. And that is an example of a classification model. That's why NLP is also an example of classification. Okay. Let me see who can answer this. What is true about classification? Come on, tell me. Give me the right answer. Who can give me the correct answer? What is true about classification?
Labeled data, confusion matrix.
Shanti, you're saying labeled data, confusion matrix. Okay. Anybody else? What about Rohit? Others? Shravani? Try. Jamila says A and C. Okay. Shravani says A. I don't know, Shravani, for which question you're saying? 11 or... Okay, so let me go to the options. Rohit is saying C and D. Unlabeled data, no. Labeled data, correct. Confusion matrix is correct. Prediction boundary. Where did you hear this word prediction boundary? Did you hear a prediction boundary when I was explaining? Somewhere? Did you hear this word? Where did you hear this word?
Maybe in regression, sir.
Which regression? Remember this? In logistic regression, do you remember I talked about a prediction boundary separating the predicted 0 and predicted 1? And these are the greens in red and red in greens, whether the type 1 and type 2 errors. Remember this, right? If when I talk to you, this is the prediction boundary. Right? So prediction boundary is relevant. So the answer is BCD. That's why I was a bit skeptical somebody will giving this as the answer. But yes, that's why I showed you why we have to use prediction boundary. Okay. Last question. What are the various algorithms used for classification? Tell me the answer for 12. Algorithms used for classification. Shanti,
Sir,
what is the answer?
I think B, C, D, E.
B, C, D, E. Okay. Anybody else? Rose is saying,
Logistic regression,
yeah.
KNN, sir.
Why only logistic regression K? And what about random forest decision tree? We did all that, right?
Yes,
We
sir.
already showed you. Then why you are excluding that? So it has to is B, C, D, and E. KNN obviously I didn't cover, but I had told you, right? KNN is one of the also the classification models like your support vector matrix and the naive Bayes and so on, right? Naive Bayes classifier, right? So yes, the answer is B, C, D, and E. Okay. So that covers my theory and practical session for the machine learning using Python for these 2 days. Any questions? Anybody has any doubts? And please, I'll be sharing everything, all this with all of you. All the data sets, scripts, you can use this for some of you want to do a mini project using this, please go ahead and do it. I have no problems. Okay. Understanding the concept is very important. Then obviously you can just create mini projects as per your requirement. Any questions, guys? Okay, ma'am, I think I'm done. So I just wanted if somebody can give some formal feedback about the session, and while you have taken a something verbal feedback, I'm sure you'll be taking some formal feedback later as well. But if somebody
Sure,
wants
sir.
to come forward and speak something about this session, that'd be very nice.
Sir, before someone talk, I just want to thank you for enlightening us with machine learning concepts because these people are having machine learning subject.
Mm-hmm.
So this will be helpful for them, and most of them are doing projects on ML.
Very good.
So we would like to thank you from PSCM CET, sir.
Yeah, that's my pleasure actually. Absolutely. I enjoy teaching students, and that's my passion.
Yeah,
So,
thank you, sir. Thank you so much.
anybody wants to give some feedback? Shanti, what is your feeling about the session?
It's a nice journey with you, sir.
No, but did you guys really learn? That is important. Journey is one aspect. Have you guys learned something in this, whatever I have taught, and you can use it to create some projects on your own? At least you can make a good beginning and know once the concepts you are clear, then you can do a lot of things. That's very important. Okay, what about Shravani, Rohit, Jamila? Anybody? Because guys, you all are final year students, ultimately you're going to get into a job. This is the time you should speak. Okay, ma'am, I think fine, you can take a formal feedback and let me know later as to overall so that I can come to know. That's fine.
Yeah, sure, sir. I will share the feedback through proper channels, sir.
No problem. Not an issue. Not an issue.
Okay. Thank you, sir. Thank you so much.
Thank you very much, guys, and happy weekend to all of you. Bye bye.
Thank you, sir.
sir.